So good morning, everybody, and welcome to the Precinct First Stakeholder Workshop. My name is Jenny Rainbird from Intercom Commercial Pathways, and Intercom Commercial Pathways are the coordinator of the Precinct project, and I'm head of EU project delivery at ICP and the Precinct project manager. Precinct is a 2-year international collaborative research project which started in October last year, and it brings together 40 technical experts and domain experts looking at understanding the challenges of protecting critical infrastructure in Europe. The vision of the Precinct project is to bring together critical infrastructure stakeholders in a geographical area and have a common cyber and physical security management approach to protecting critical infrastructure in that area, considering the interconnectivity of critical infrastructure and the cascading effects that an attack can have on other infrastructure in that area. We have a full program in this workshop for you all today. This morning, we'll be hearing from some of our technical experts on some of the key components of the Precinct project. And then this afternoon, we have some roundtable workshops. The idea behind today is to have you who have joined us today physically, but also all of you that have joined us online, participating in the meeting. So please raise your hand if you have comments or questions, or type in the chat online, and we will get to as many of you as we possibly can. Today's meeting is going to be recorded and will be available on the Precinct website after the event. So I will now introduce our first speaker, Gabriel Günther. Sorry, I have the old glasses on. Gabriel is a senior researcher and head of the Smart Transportation and Infrastructures at the Industry and Security Technologies Research and Innovation Lab within Engineering Research and Development Department. He's been working in the Engineering Informatica SPA lab since 2000 in multi-sector Italian and European research projects, some of them focusing on critical infrastructure protection, such as Defender, Infrastress, Seven Shield, Eurosec, and of course, Precinct, playing several roles such as solution designer, system architect, technical manager, and project coordinator. So I will hand over now to Gabriel, who will be talking to us about the main key results and the Precinct roadmap. Thank you.
Thank you, Jenny. Thanks a lot for your kind introduction, and good morning, everyone. It's a pleasure to me to be here today to this first workshop to present the results of the work package 1. I cannot see the slides. I don't know if you are going to share slides. Yes. Okay, yeah, probably that should be some slides here. Let me check if it is possible to. Okay, so the work is related to the work package 1. It's a work package on the present reference framework specification, where we are going to define the main specification to that's fine. The main specification to have a security to improve the security of the critical infrastructure and having an effective resilience management. Now in my 15 minutes presentation, I'm going through the work done in this work package, giving key relevant information about the key results and the future work. Next slide, please. As I said here, we are going to define the frame of reference. This is the main reference framework that is going to be used as a baseline and for all the other work packages, including the work package where the pilot will be carried out. As a first step that we made in this framework reference was to start identify the critical, the main cyber physical threats and natural hazard threats affecting the critical infrastructure, with particular reference to the infrastructure that are located in our 4 living labs. It was a combination of cyber physical hazards. It was done analyzing the main threats, and according to a specific methodology defined by ICS, that is one of the members of the PRECINCT consortia, it was possible to have a list of threats, a list of potential hazards, to analyze, duly analyze also the potential cascading effects with the specific focus with the escalation point in case of disaster. There was also possible to have a better understanding of each individual assets from the risk assessment point of view, like those are related to the installation plans, but also having a specific focus to the employees, to the infrastructure, to the surrounding population in areas, to having also societal environmental attributes. And it was possible also to make such kind of analysis, also analyze the magnitude scale of in case of disaster damage. At the end, it was proposed and provided a work within a deliverable that unfortunately it is EU restricted, so it is not possible to be shared in a public version. But in this deliverable, it was possible also to have a list of such representative threat scenario and the related sources. There was also a combination with the threats and the scenarios were taken into account in the other relevant research CIP projects. And it is something that might be considered as a sort of a baseline for the other work packages, including the pilot activities. Next slide, please. The second major activity that we made in the specification of the framework reference, PRECINCT framework reference, was in terms of, as also Jenny said at the beginning of the workshop, PRECINCT is also quite focused about the interdependencies of critical infrastructure and the potential and analyzing the effective of the cascading effects. In this work packages, there are a couple of tasks that where partners are mostly focused, involved in the analysis of the interdependencies and the evaluation of the cascading effects. Specifically in this work was done an identification of the modeling frameworks in terms of dependency graph and cascading effect simulations. And it was also done in strict collaboration with the RDS. It is another partner, another member of the consortium present that is specialized in the resilience framework and the resilience methodologies. In the specific case, using this kind of dependencies graph, it was possible also to start analyzing at the first 2 living labs. One is in Ljubljana, living lab 1, and the second is in Antwerp, that will be also presented during the today workshop. And through a very focused and interactive workshop, it was possible to start to identify the main elements and to provide such kind of dependency graph model for such 2 different workshop, different living labs. And in this case, also the discussion was also focusing on to identify what was the local dynamic approaches in order to make an effective simulation of the cascading effects. Most of the work is already available in terms of with an internal version of deliverables, so not yet finalized and not yet publicly available. But there are a couple of papers that were submitted in mid of April that will be ready in a very few weeks. Next slide, please. Here it is an example of the dependency model for the Ljubljana Living Lab. You can see on the right side there are several nodes with the different shapes interconnected each other. This is something that allows us to identify the main interdependencies, the main elements. In terms of components, relevant components, we have here all the components that have a crucial role in the critical infrastructure, like the transportation nodes, so like the telecommunication and the energy nodes, and with the involvement of persons. So in that case, we have a staff for security staff, we have also infrastructural staff, policy staff. It is something that is modeled through this dependency model, and where in the specific case of the Ljubljana Living Lab, it was done to identify the main threats and to see how the main threats, like physical threats or cyber threats, might be simulated and might behave in order to analyze the possible cascading effects looking this such kind of interdependencies. It was also done with the stricter collaboration with the RDS in order to see which kind of evidence we have in case of some kind of attacks, considering some kind of resilience indicators for each individual nodes that might affect also the final evaluation, the final assessment. Next slide, please. In this slide, it is represented the second interdependency model for the second living lab for Antwerp, where we have different nodes for different in critical infrastructures involved, as well as different kind of roles for staff. And this was done for the threat. We have analyzed there is a different threat with respect to the Ljubljana, because in this case we are analyzing the natural hazard like flooding. Next, please. In terms of future work for such kind of activity, the next two living labs will be addressed. So we are receiving a first input from them in order to identify the same interdependency model in terms of main assets and main persons that are involved here in these two different labs. Of course, more or less the approach is the same, having focusing workshop and focusing meetings with the involved stakeholders, involved partners. It is also possible to have a look at the cascading effects simulation models for all the living labs. Here, as you can see, there are it was done for Antwerp for the flood, and it is possible to see how the threats might evolve. And in that case, in order to see how to address each individual threat, there is a specific discussion that has been started with the involved stakeholder in order to see how to mitigate such kind of threats. The discussion of how to integrate also the resilience framework with the interdependency and knowledge and the cascading effect models has been started as well. And it is also ongoing, the integration with the serious game that is part of the work package for and will be discussed and presented in the next presentations. Next, please. Another important aspect that I have mentioned is related to the resilience methodological framework that is being developed in PRECINCT, starting from previous work coming from research projects like Smart Resilience, Resolute, Forestry, Resilience, and EU Circle. In that specific case, we started from standard for guidelines for assessment of resilience and transport infrastructure. That is the CW8 17819. And it was extended, of course, for other domains like energy, telecommunication, and yeah, in that specific case, normally the approach is qualitative and quantitative approach, while in the last few years there are relevance and that the quantitative approach is considered one of the most effective one. I don't want to go through this kind of the definition of the resilience or talking about the resilience model because it is probably out of the scope of this workshop. I would like to go through to present next slide. In the next slide will be presented the resilience methodological framework defined by RDS. It consists actually in several steps, starting from the identification and the quantification of the services in terms of the value of service, and in order to identify the quantity of services, and going through the resilience in terms of resilience indicators that with the special have to be defined in order to check the relevancy or to estimate some kind of values. And at the end, it is also possible to make a sort of estimation of the percentage of fulfillment of the indicators and the indicator strat for each indicator strat categories. It is something that is going to be done considering a set of targets that are the targets are in terms of requirements. So the legal requirements that we can consider interacting with the Living Lab owners, Living Lab members, or the stakeholder requirements. After that, it is possible also to identify for each critical physical and hazard, critical physical threats or hazard. It is possible to identify such kind of targets, and the cross consideration of the resilience enhancement is the final step. Next, please. Going ahead towards the definition of this framework reference, here in this activity, we have focused in our work on the analysis of the vulnerabilities for each critical infrastructure, or considering the cyber and physical attacks or the natural hazard defined in the previous, let's say, introductory work. And it was such kind of analysis was done basically analyzing the literature or the existing critical infrastructure projects and considering the public results, or to have a look to our Living Labs and to see which are the main expertise and the main knowledge that we can collect from them. We have also analyzed the current cyber physical protection solutions and technologies, looking at the state of the practice in the current critical infrastructure or the current research projects. And we have also considered a set of different resilience management models. Those belong to the cascading effect interdependency graph. Those are related to the resilience models, and those are related to the organizational and governance models that comes from the reference projects. Next, please. Here, one of the main important things that we addressed was to identify the main taxonomy in terms of risk, and considering also part of the framework reference, a sort of glossary, in order to have a common understanding about risk and about potential threats. We have analyzed the ENISA taxonomy or the open fair standard, that is a risk taxonomy made available by the ORDRT, or the Department of the Homeland Security taxonomy, including also the ISO guide and the Cambridge taxonomy. Once we have identified this taxonomy, next please. We have also looked at the existing taxonomy in some European research projects like SATI, Defender, and PRECINCT, and we have also analyzed the vulnerability and the critical assets of different living labs. Next, please. Here you can see a list of research projects operating in the domain of the security of the critical infrastructure protection that we have analyzed. Most of them have a lot of public results that we have assessed in order to make an effective evaluation of our results. Next, please. In terms of current technologies, we have also investigated with the current living lab what kind of technological system and operational procedures was put in place, and in order to identify our baseline for the future work. That was done with interacting with the living lab, but something is also still needed in order to finalize this work. Next, please. In terms of main results, here we have to provide a collection of catalogs that are the resilience service model catalog. We have collected one catalog from Antwerp, considering the list of resilience indicator to measure a specific level of service. And another one was collected even in Antwerp in terms of interdependency graph and cascading effect. Other catalogs will come in the next months for all the other three living labs. And once we have assessed such domain, we are going to also to identify potential systems and measures for each individual living lab that will be identified in terms of digital twin, knowledge graph, big data infrastructural services, and situational awareness. Next. Well, I'm going to conclude my presentation just to give you a brief overview of the business and technical requirements and specification approach that consists of the specification of the business, technical, and standardization requirements. Each of them has already a set of key results like in terms of market segmentation and stakeholder analysis, or in terms of description of the main present platform solutions and components, interaction among them, and information flows. In terms of standardization, there is also identification of the relevant standardization committees and analysis of the national and international standardization body results. Next, please. Okay, this is my last presentation where we have also potential, we have also planned the future work in terms of business and technical requirements. So we are finalizing the business requirements and the value proposition. All of them has been already documented in terms of interconnection between the different components and dependencies. And we are updating the standardization strategy and landscape. That's all from my side. Thank you very much. I hope to be time.
Thank you very much, Gabriele, for that very interesting introduction. We have time for maybe one or two questions while our next speakers are getting ready. So please, do you have any questions from the floor? Please go ahead.
Hi, Gabriele, thanks for that. You talked a lot about the reference or resilience frameworks. Can you explain in your perspective what are the benefits of those frameworks for perhaps for the project itself, but eventually for users in the end?
Yeah, sure. Thank you, Mark. Well, actually, PRECINCT is a very challenging and complex project. We have, as also mentioned by Jenny, we have a consortium of 40 partners, 40 partners. So a lot of partners, a very big consortium. And it is a multidisciplinary consortium where we are putting around the same table technical expert and domain expert. So in one of the main benefits of this frame of reference or reference framework is to identify a baseline, something that has to be used by all the different partners with the different expertise in order to talk the same languages. It is important to have a glossary, a taxonomy of the threats, a taxonomy of risk, in order to be all of us aware about which kind of risk or threats we have to address, to talk the same language in terms of glossary, because it is important to, from technical and domain perspective, to have the same information at the same time. And having, as you have seen in this reference framework, we have started analyzing the main threats scenarios, so for each individual living lab. So now we know exactly what we have to protect against what. And we have also started analyzing the dependencies among the different critical infrastructure assets and the involved stakeholders. And at the same time, we have also a look at the resilience, because the resilience is another key point of RECINCT. So altogether, with the existing work coming from the existing research projects, public results that might be used as a sort of baseline where we can start on, and at the end, the specification of the business and technical requirements is the final conclusion of this such kind of framework reference. So having such a reference in our hand, we can address all the other work packages having a common background. So it is important also to stay all of us on the same page, to have the same mission, to be focusing on the main challenges. This is why I do think it's the main benefit of this framework reference.
Thank you very much for that explanation. Thank you. And thank you for the question. Great. So if we can move on then to the next session for this morning. So we have Gabriela Armando Kuntush and Estafos Zavos, I beg your pardon, who are going to talk to us about the blueprints and knowledge graphs. Gabriela received his PhD in machine learning and indoor localization from the University Françoise in de Tours in 2013. He worked at IMT Atlantique for more than 3 years as a postdoctoral researcher on RockerWeb and Scoop at F Project. He joined ACCA in June 2018 as a project manager, managing several projects, and his fields of expertise are machine learning, security, privacy, cooperative intelligence, and transportation systems and wireless networks. Please join us. Estafos Zavos has received his PhD in computer science at the University of Southampton in 2019 and is well versed in several artificial intelligence areas, including machine learning, intelligent agents, game theory, and genetic algorithms. He is currently the head of artificial intelligence at VLTN BV, where he is involved in several Horizon Europe projects. So welcome, thank you, and I will hand over to you.
Thank you. Well, so good morning, everyone. It's a real pleasure for me to have this occasion to meet you all. I'm going to present with my colleague Statis one aspect of the work done in Work Package 2 regarding what we called PRECINCT blueprints. So this presentation is going to follow this agenda. I'm going to present, first of all, our main goal, what we call similar approaches, and then the work, how we carried on the work in PRECINCT. So our main goal, as you see, there have been lots of previous projects regarding the protection of critical infrastructure. And also there are ongoing projects where a lot of knowledge and know-how have been derived. And so our main goal is to reuse this work and provide it to be easily reusable. So you see that PRECINCT is part of this cluster of projects, and all address similar and other aspects. So how are we going to address that? Our objective is to provide those tools or knowledge, to package them so that you can use, for example, a tool such as Ansible from what we call the PRECINCT blueprint repository, clone it, and then deploy it on the Living Lab or to test it in a local environment. So what we call reusability is that you get the blueprint, for example, for protecting a given critical infrastructure. And then this blueprint is deployed, tested, experimented on, and then you can derive outcomes, for example, domain-specific knowledges. And then you can also reuse this blueprint to make it publicly available for other partners and other projects. So let's say that in PRECINCT, for example, we have a serious game or a digital twin or a knowledge graph. So this knowledge graph is developed by one of our partners, and then this partner can make this knowledge graph available in the form of a blueprint with a description. And then this blueprint can be, this knowledge graph can be used in a given Living Lab. This Living Lab will derive, will apply this knowledge graph, and then will derive some specific recommendations, or and then we'll say we'll provide, let's say, feedback about this knowledge graph in forms of configuration files and so on. After that, the same process can be reused. So the domain-specific knowledge can be also provided in form of a blueprint. So this approach is already existing, where in order to provide the blueprint, you need to describe your tool or in form of a reference architecture. So let's say that we have this big data infrastructure that will be used in Work Package 2. And you can have different implementation of a big data infrastructure, but you need to describe or to have a reference architecture which is independent from a given implementation. From that, we have also another project called Akraino, where they are providing blueprints for 5G and edge computing, which can be easily reusable. So you see a blueprint is described, let's say, with an architecture, a documentation, and it has also a life cycle. So similarly, more and more, you have cloud providers which are providing what they call blueprints. So you can use the user interface from Google or Amazon. And then if you want to deploy big data infrastructure, or you want to deploy a different service, there is a description and tools to easily deploy your solution there. So in PRECINCT, we are going to adopt the same approach, where we reuse knowledge from previous and ongoing projects. We derive reference architectures, and then we provide the tools to easily deploy those solutions for the Living Labs or other partners. So The problem is that you have several tools to do that. Each cloud provider provides different tools, for example, Terraform, CloudFormation, Cloudify, but also you have tools like Ansible, Puppet, that all they provide different languages to describe how you are going to implement this blueprint approach. So in Precinct, we are proposing to use Oasis Tosca. So Oasis Tosca is a standard where which is above, let's say, different cloud providers, and it provides a language to facilitate the deployment and the orchestration of cloud application independently from the cloud provider. And so you see, you have what they call a topology template. And this topology template represents the reference architecture that you saw earlier for the, let's say you want to deploy a big data infrastructure. So you will translate the reference architecture in terms of a topology template, and then you go on for the different component of this. I will show you an example how we apply it in Precinct. So in order to understand how we are going to apply this approach to Precinct, let's say that these are examples of tools from Work Package 2 that are going to be provided from Work Package 2. There are from Apache Kafka to a solution from our colleagues from engineering called Alida. So these are examples from tools in Work Package 2. And then we organize those tools in what we call final tools, intermediary tools, and basic tools. And these tools, they have what we call capabilities. So some of those capabilities can be security and so on. So you see that we organize the tools, we define among them hierarchies, and those tools provide capabilities, and they have also requirements. So from that, we you see that this is the Precinct ecosystem platform. So this is the outcome of Work Package 2. And then we organize the solutions in terms of, for example, semantic connectivity and integration. These are a set of tools. They can be considered as final tools, and also AI and big data and the unified situational awareness. So all these blocks, they use some of these basic tools to provide what we call the semantic. So now we are going to go to detail what we call the semantic connectivity and dynamic infrastructure. So you see, this is a detailed description of this component with all its subcomponents until we reach the basic tools. So then we are going to detail and describe this as the reference architecture with documentation and a lot of description. So we agree on the interfaces, the capabilities of the subcomponents, and then we are going to reuse all this approach to deploy the Precinct ecosystem platform as a blueprint. So the blueprint is the reference architecture described with all the tools provided in a GitLab repository, where you can use tools like Ansible to deploy it in the Living Lab, dedicated resources, or at the partner specific test environment. So this is the overall approach of the Precinct ecosystem platform, and it's my last slide. Hope you.
So now our next presenter will be joining us online. I already introduced Stathis Savos from VLTN. So Stathis, please, the floor is yours. Thank you.
Hello. I'm going to pick up from what my colleague Gibrila described to shed a little more light into the use of knowledge graphs in PRECINCT. And you will excuse me, but I'm still recovering from illness, so I'm not 100%. If we can move to the next slide, please. So today we're going to talk about what knowledge graphs are and why we use them. And we will talk a little bit about the model of critical infrastructures in PRECINCT at a high level and an example of cascade effects from the real world. And then we will conclude with the kinds of results we can obtain using these knowledge graphs and some services for exploiting these results. If we can move on, please. So when we talk about knowledge graphs, we mean using graphs to represent real world situations or objects and their relationships together with relevant information tied to these. And to visually represent a knowledge graph, in our case, we use nodes to represent critical infrastructures and edges to represent the relationships between them. And these relationships have a direction from one infrastructure to the other, as in the shape below, and we use labels to tell different infrastructures and relationships apart. Next one, please. So each critical infrastructure can have different states and properties associated with these states, like whether the infrastructure is operational or not and to what degree. And here we see a table that maps input events for an infrastructure in question, the change of state these events may trigger, and the probability with which these state changes may occur. And what is really important here is, because we talk about the cascade effects, is a relationship with other infrastructures that will be affected from a change in state of this infrastructure. And of course, input can be physical, like an input event can be a physical event, or it may be a cyber event. Or it can also be the change of state in another infrastructure earlier in the network. And if we can move on, please. So we come to the question of why use knowledge graphs to represent critical infrastructure networks. Well, first of all, this enables the ingestion of different data sets at different times. So we can make a knowledge graph out of a data set that refers to some objects, some infrastructures, and then we can come back and enrich this graph by ingesting a new relevant data set. And this process helps create a map of objects within our domain and their relationships, as well as any associated information we may think is relevant. And many times this mapping is done automatically by using some sort of natural language processing. Now, in the knowledge graph, each object and relationship can have a series of properties or descriptors. And when the knowledge graph is complete enough, we can then search it to answer difficult questions, about very complex processes in a very efficient way. And if we can move on, please. So if we look at a real world example, so I've used the disaster in the Fukushima nuclear plant some years ago as an example here. So as you may know, events that they started with a large earthquake off the coast of Japan. So after the earthquake, the plant was programmed to automatically shut down the nuclear reactors. And as a result, it stopped producing steam, which in turn stopped the electric turbines from generating electricity. And this also stopped the reactor coolers, because the reactor coolers in a normal cycle are fed with electricity that the reactor produces itself with the turbine. So now there is a backup system, of course, to feed the cooling system in that case. And these were initially located at the basement level, together with a power switching station that distributes the power from the generators. And of course, they had thought of that before, that, in case of a tsunami, this may be a problem. So they built new generators at some point up on a hill. And now the earthquake has caused a large tsunami. So the tsunami floods the basement levels and the old generators get knocked out, but the power switching stations also get knocked out. So the new generators on the hill do work, but still no power can reach the coolers anyway. And this leads to the catastrophe. And this just goes to demonstrate that having models and services like the ones we're talking about here can really help predict catastrophic cascade effects. And importantly, it can help develop and lobby the proper strategies to counter these and recover by providing, appropriate evidence. And if we can move on, please. So now we can say that the knowledge graph is a stored representation of the model and the related information into databases. There's what we call graph databases usually are used for this sort of storage. And having all these stored in this way allows for easy access and navigation, as we said, of the infrastructures model. So in reality, infrastructures may connect back to other infrastructures early in the chain, and each input event in each infrastructure can lead in many cases to any from a given set of states. And of course, for each infrastructure that fails, this can affect different infrastructures according to the failed infrastructure state. So this can be a very complex situation, and the knowledge graph binds all this knowledge together to make it convenient to navigate the model. For example, to evaluate the expected cascade effect of an initial set of events. And if we can move on to the next one, please. So what are some results we can get by using knowledge graph? So first of all, we can use the existing knowledge graph to create new knowledge. And this can be done by processing the data that already is there and identifying properties and relationships which maybe were not evident previously. And of course, we can generate new knowledge, as we said, by ingesting new data and expanding the graph. And another result we can get is to be able to respond to threats in time. So given an event happens, we can figure out what the expected cascade effect is and take appropriate action, as we said, by navigating the model of infrastructures. And another important result is we can, before an event happens, we can hypothesize about what the expected effect may be. And we can do simulations and we can evaluate the response of the system. Next one, please. So we can build a set of services around the knowledge graph to exploit these results. And these services can help provide insights to evaluate resilience and also to determine actions of interest and potential investments. And other services can optimize efficiency in a number of ways. For example, we can choose to invest more towards, averting more disastrous effects, or towards more likely events, responding to more likely events, whatever our criteria are. We can also optimize operations and critical infrastructures themselves. And very importantly, we can bounce back from events faster and cheaper. And that is, we can optimize the cost of achieving, the level of resilience we desire. And finally, these services can also assist decision-making by suggesting actions upon the occurrence of an event. Also by being prepared with an action plan, which is based on, simulations that we've done before. And also we can use the system to review suggestions on the spot and to help us make better informed decisions. And of course, if we wanted to, the system could act completely automatically if it's robust enough and we think we can trust it. So yeah, thank you very much. And if you have any questions, I'll be happy to answer.
Thank you very much, Stathis, and thank you both for that very interesting overview of blueprints and knowledge graph aspects of the PRECINCT project. I think we're running a little bit over time, but we think we have time for just one question, if there is any, before we move on to our next session. Okay, if we move straight on then to our next session, I'd just like to bring our presenters up here. One moment. Thank you. So welcome to Dr. Daniel McCrum, Assistant Professor in Structural Engineering at the School of Civil Engineering, University College Dublin, Ireland. Daniel is a Programme Director in the School of Civil Engineering, and in the past he has been Head of Teaching and Learning, and his research is focused on the critical infrastructure protection in extreme events, modern methods of construction and integration of serious gaming to critical infrastructure protection. So over to you. Thank you very much.
Thank you very much. So very warm welcome and hello to everyone here in the room for the first time, which is really good, and hello to everyone online. A slight change to the agenda. I'm presenting today instead of Ili, another postdoc work on the project, but what I kind of decided today would present is kind of give you a feel for what the serious game will do. So the first few presentations have talked about certain aspects in the project, and I just want to give you a flavor for what we plan to do for Precincts. We want to create a serious game that can help critical infrastructure owner, operators and users understand their resilience and also use it as a training tool. So the overview is quite straightforward. I'm going to talk first about the kind of all the steps that are involved in the game, okay, and then the data mining framework. So how do we understand, you know, as users of the game, how will we understand and get insights from the game? And the storyboard will kind of be like a screenshot kind of a version through the game, so to speak, to try and help people understand what we're trying to achieve. So first off, obviously, it's been discussed in the last few presentations, but we start off with these interdependency graphs. Okay, this graph-based approach, we have one critical infrastructure, you have nodes within it, you have a second infrastructure with nodes within it, but importantly, there are links between them. Okay, so, and following on from that, you can assess the vulnerability and the resilience of these nodes, but you can also assess their cascading effects. So, as has been discussed previously, what happens if you have a flood? Does it a knock-on effect to different aspects of your network? So again, this is where we're talking about resilience and cascading effects coming together. They'll come together in some form of a digital twin or be stored. That information will be stored somewhere, and then we'll move on to the game. That information will be used in the game. So the game will be a GIS based, so geographical based view. There'll be 3 players, well, 2 players and a director. So I'll talk a bit more about that later on. So in terms of how does this gameplay work? They'll register these users. Okay, so they'll register and then they'll start playing the game. So the example I'm going through today is Antwerp, which is one of our living labs. So the precinct of Antwerp, so to speak. And it's a flooding example. So the reason I'm presenting this one is because we're a little bit further developed in terms of thinking about Antwerp than maybe some of the other living labs. Step 6 then, once you finish playing the game, is we're going to use machine learning techniques and data mining to help us understand your gameplay. So how can you gain insights from the gameplay and repeated gameplay? So you keep coming back and playing and training and playing and training. How can you learn from that? And finally, you'll get some gameplay records again. So this will be some sort of reporting structure towards the end. Okay, so apologies for the text at the end. And that comes back to the users. In terms of the framework, I'm just going to go quite quickly through this. It's something we're starting looking into now in more detail because we're starting to reach out and start to develop this with the Living Lab partners over the next month or so. So obviously you get the data in, you extract what you need, you process the data, and then we'll use machine learning techniques to help us get recommendations, you know, short-term, long-term, and then finally we'll get statistical summaries, visualization as well, because visualization is important because obviously you've probably seen from the last 2 sets of presentations, this is quite complex, you know. So how can we visualize this and simplify this down so that the users can actually understand their systems, you know, what's their vulnerability, what's their resilience, they can understand that, but also that they can gain insight from that. How do we improve? How do we make things better? Okay. And the final section is the longest section of the presentation. And this is a storyboard that we've put together to try and help people understand what we're trying to achieve through the game. And we've done this visually because I believe visually is probably the best way to present. So these aren't actual in-game, but these are the concepts that we're going to be presenting. So it'll be a web-based application. So you log in, here's your storyboard, the user logs in, username, email, password, whatever. So the people who are playing this will be trusted members of staff, obviously within the critical infrastructure, the individual living labs and within their precincts, so to speak. Here we have just character selection. We have a director, we have a defender and an attacker, okay? So the director is going to be responsible for deciding what we're doing, okay? So we're going to set out the game, we're going to start the game, and this is the scenario we're going to look at, okay? This is the scenario we're going to look at today, okay? That you have a defender and you have an attacker. So there could be a scenario where the director sets up a game and then we only have a defender. Okay, so we try a response to a threat. So we have a flood event and we see what our resilience is in terms of our networks, okay? And then maybe we only need a defender to try a mitigation strategy. So that could be one way of playing the game. Then there's another way of playing the game is a two-way kind of attacker and defender. So today what I'm going to show is the full attacker defender kind of concept, okay? So here we select the director. The director doesn't play the game, only the attacker and defender play the game. But the director's role is very important. You could see the director potentially being, you know, like managing a response to an incident or something. They could be that person, you know, or they could be that team of people, okay? So here we have, you know, a concept for the dashboard. So we have the physical attacks, you know, you're going to program all of these different physical attacks in terms of the cascading effects, the resilience, etc. calculations to be populated for whatever you want to be looking at, okay? There's cyber attacks here today. In this example, we don't have a cyber attack, but cyber attacks would be in there, denial of service or ransomware. Okay, so the director decides what today we're going to be looking at is a flood attack. Okay, it's going to be a level 3 flood. I mean, I've just put in the number level 3. It could be 4, 5, whatever. Okay, level 3 means nothing to me, but it might mean something to you. Okay, and then they decide where's the location. Well, it's going to be Antwerp. Okay, and the budget. Okay, the budget is a nominal value. Okay, of 8,000 euros, and this is the budget towards the attacker. This is what the attacker is allowed to spend. Okay, so if the attacker were, you know, an international organization, their budget would be very high. If it's a lone person, their budget would be very low, that sort of thing, okay? So here we have, these are the different critical infrastructures. We have the communication, energy, transportation, and water, and we assign a defender budget to each of these, okay? And the reason we're assigning budgets is because, you know, in the real world, that kind of fits in, but it also feeds into the resilience metrics are going to be based around a monetary value as well. So it kind of feeds into that really, really well. There may be extra resources or things that each of the individual living labs may want to include. And I just threw in something here on interest rates of, you know, maybe that's interest, I'm not sure or not. So then we go back to the character selection. We have a look at the attacker. And the attacker might see a screen something like this, maybe a simplified version of this. You can see they have their budget of 8,000. You can see the attack tools there. So again, these are the attacks that have been predefined and set up. We know the cascading effects. We know the resilience scores for these as well, okay? So in this example, there's a flood. That's the original threat. And you can see in the top left, the assets. So we might be looking at a tunnel, a road, a bridge, or whatever. So the attacker is going to attack those assets or one of those assets, okay? We could also include something like noise, which you see in the top right here. And this could be like a traffic accident or something, or maybe just, you know, bogus information. So we may include that, we may not. It depends on the living lab partners, what they might be interested in. So here, this is the example of the attack summary. So it's a rainfall event. It's been budgeted 3,000, so they lose 3,000 from their 8,000 budget. There's a buffer zone, so the zone in which this affects. There's a magnitude in terms of millimeters, the intensity of rainfall, the speed of the wind, whatever the metrics that are required to perform the calculations, okay? Whatever metrics then are required, okay? So there it is. And what's happened now? So we had an original state, okay, an original state of resilience. We had a flooding event, the resilience has changed, and we now have an attack event. So the resilience has changed again. So the question is, how do you keep track of this as an infrastructure owner and operator? What we're looking at here is the example we're looking in Antwerp is the Kennedy Tunnel. What would happen if this happened to the Kennedy Tunnel? We then come back to the user logs in and a separate user logs in as the defender, okay? So can they put in a mitigation strategy in here, okay? Can they do that? And will it make a difference, okay? So here, the screen that the defender will see, it may have information about previous games that they've played. You know, how did they rank? Did they rank poorly? Do they need to improve? Here, the threat has been set as a physical attack, as a flood. It's been set by the game director. It's a level 3. And they'll input other information like their role and also maybe their years of experience. So these are metrics which we'll actually use in the gameplay analysis, okay? So how are our individual game players performing, okay? Is there something we can learn from that? So the defender goes in, they click into the screen, and they'll get something like this, hopefully by the end, okay? And what we see here is we see the geographical representation of the flood. This is the flooding event, a level 3 flood. On the top right, we have an information button, and it just tells us what all the other icons mean up in the top left. Okay, do you want to do a geospatial analysis? Like what's the current condition of your critical infrastructures? Okay, etc. And expenses distribution, which I'll go through later. So along the left, the geospatial analysis, you know, you could just look at the affected site or the degrees of flooding, or you could click in and look at the resilience, okay? So these are examples from other projects. We haven't done the analysis yet. But if I just zoom into one of them, this is an example of a change in resilience in a transportation network, okay, before and after an event. Okay, we're more looking at nodes in our interdependency graph, so I don't think they look exactly like this. Okay, so, but it's information that will be provided. The risk level, so this is all relates to resilience. So if we can see in the center at the top of the screen, we have C is for communication, E is for energy, T is for transportation, and W is for water. And the values will all, you'll get some sort of metrics around. In the previous 2 presentations, they've been talking about this change in state. You know, when something happens, there's a change in state, okay? So that change in state, is the infrastructure still good, or is the infrastructure now inaccessible, okay? And that will update then. You'll understand then the change in your resilience, and I've shown one along the bottom there that we'll include resilience enhancements later on as well. Along the bottom, then you have this kind of, it's kind of probably people are quite familiar with this sort of concept. You can click in and have a tutorial. You can save your solution as you're going along. You can stop the game. You can skip the game forward, etc., and exit. You know, a similar kind of idea. Finally, here, this I won't go into too much detail in these, but if you want to look at you know, your expenditure here, I'm just going to look at the table version, not the map version. And this links in quite well with resilience, okay? So if we see here, we have our 4 different critical infrastructures. We have communication, your energy, transportation, and water. So what's the current state of resilience, okay? And then the threshold, maybe you set a threshold level of resilience, okay? So we don't want to go below this value. You could also set a target level of resilience. We haven't shown it here, but maybe there's a target level of resilience you want to achieve, okay? You have a budget that's been assigned by the game director here, and then additional resources. So this could be an example where you come back and so let's say flooding of the Kennedy Tunnel, maybe you deploy sandbags. It's a very cheap thing to do, okay, but it mightn't improve your resilience very much, okay? Or you could completely repair the bridge or the tunnel and make it fully resilient, and it costs a lot of money. Okay, but you have real enhancement in terms of your resilience score. So they're the kind of concepts, you know, that you'll be able to visualize. And that's what the game is to help us do. Oh yeah, sure. Okay, skip that one then. So here you just see that you have the change in percentage of resilience. And then I wanted to jump back to this and say, look, we will be putting in some aspect where you can view the interdependencies, because a critical part of this project is the interdependencies. It's not just the fact that you have individual critical infrastructures, it's about the interdependencies. So if you can understand that water and transportation are highly linked. I'll skip past this one. This one is just, I'm short on time. I'll skip through that one. And then finally, you have some sort of gameplay analysis or reporting that will come back to the users at the end of the series game. Done. Is that okay?
Thank you so much.
Okay.
Sorry,
That's no problem, no problem.
sorry, sort of
No,
thank you very much. It was a really interesting presentation. I'm sure everybody can agree. We can just maybe have time for one question if there is one from the floor. Nope.
Yes.
Yes. Okay.
Can you hear me?
Yeah.
I think there are one and two or just two. So how did you come with the potential solution in the game theory?
So we came to the solution. Well, I mean, I suppose we didn't present it here, but there's a lot of background research that's gone into that. And a lot of the slides that we present and the solutions we present are based on state of the art. But we had a workshop with a provisional workshop in January with all the Living Lab partners. And this is this is what we'll take forward to the Living Lab partners. We're meeting them in May and June, and we're going to get bespoke solutions to how they want to move forward in that respect. So that's how we're proceeding. Yeah. Thanks. Yeah, good question.
Maybe I have a naive question, but you're speaking about budgets and your simulations, etc. But you gave the example of sandbags and building a bridge again. So I was wondering whether the time aspect was also important for calculating the resilience, because you can use a tool that needs time to be put in place, or a tool that needs short results. So how time is taken into account?
So I would have to pass that one on to Lorcan down there, but ultimately I think these are going to be discrete calculations, and I think maybe that question could come up later on, maybe in the open session. I think how they're going to include the time dependency nature, but I think they're going to be discrete calculations. But yeah, good question. Yeah. Oh yeah. Is there a question online? Yeah.
Yes. Can you hear me?
Yep. Yeah.
Yeah. I was just interested in how the idea is to make to connect the director and attacker and defender. Is this planned like have something of a matchmaking, or is it more stored and there's kind of level selection and round-based play?
Yeah, that's a good question. Yeah, so I suppose we would see that when we directly meet with the Living Labs, which we're meeting them in this month, actually, Antwerp and Ljubljana. We'll find out exactly who they want to be, those people. You know, the game director doesn't get directly involved in the game, but they set up the game, they set up the scenario, and these scenarios have been set up by the Living Labs themselves. So we already have scenarios that we know we're going to do, and one of them is this flooding scenario. What they actually want those people to achieve and how they will learn or create training scenarios as well, we're still yet to fully develop that. But that's, yeah, a very poignant question. Yeah, thank you. Thanks.
Thank you very much, everybody. Unfortunately, it's a very interesting topic, but due to time constraints, we're going to have to stop it there. But we do have the roundtable discussions later on in the day, so hopefully we'll be able to come back to some of your interesting questions on this topic. So moving on then, our next session is going to be talking about the architecture of PRECINCT and the implementation of what we're trying to create here. David Vermeer has been working at IMEC for the past 8 years and currently serving as an operations lead at the Sustainable and Urban Environment Centre. He has the role of Work Package 4 leader in the PRECINCT project, owing to his years of experience working on digital twins. So welcome, David, and thank you for joining us today, despite the fact that you're very ill. So thank you so much. Over to you.
Hello, everyone. Yes, unfortunately, the idea was that I would have presented in person in Brussels, but unfortunately, I tested positive for COVID. So sorry if you might hear some coughs during the presentation. So yeah, indeed, we will talk about mostly the contents of Work Package 4, which is focused on the architecture of the digital twin part of the PRECINCT project, and implementing that aspect of the ecosystem. Next slide, please. So after a short introduction, I'll give a brief overview of what is the contents and what the plan of attack is in Work Package 4. And then we'll talk about how we define the reference architecture for the digital twin, how we are going to approach digital twin development, because we're, of course, as you will see later, we have many pilots and even transferability pilots. So, so all focusing on different things. So that is a challenge as well. And then I'll end with showing how we plan to apply the reference architecture to the Living Labs and what the outcomes of this work package will be. Next, please. So just a short introduction about IMEC, because IMEC, I believe, is mainly known for being an R&D hub, one of the world's most known R&D hubs in nano and digital technologies, which is headquartered in Leuven. But we have many satellite offices, and we have many departments, of which I am a part of one, focusing mostly on sustainable and urban environments, and part of that is the digital twin technology stack. So we have a lot of experience in digital twins in the urban environment, but we also have within IMEC a lot of experience in cybersecurity resilience, spread out over many scientists and PhD students working across the world. Next, please. Our work package 4 consists of 3 main blocks. There's 18 partners involved out of the 40 that are involved in PRECINCT. So it is still quite a big work package. And there's 3 main blocks that kind of overlap. So the first part that's going to end in July of this year is supposed to focus mostly on the user story maps for the digital twins that we built together with the Living Labs, and focusing on digital twin architecture, or the reference architecture and the architecture for the Living Labs. The second part will be more development focused. We will create a library of digital twin components, basically building blocks for digital twins. And we also have interactions with the technical elements of various other work packages, such as the series game that you've just seen. We need to, I think it was one of the first slides in the previous presentation, we need to build integrations with the series game, but also with the AI platform tools, which will be basically a platform to serve and execute the predictive models that the digital twin or simulation will use to get insights into the underlying data. The cyber range laboratory, which is a tool to do cyber range exercises with, and the self-protection module, which protects the system itself from cyber attacks. And then finally, the last block, which will run into the final year of the project, is instantiation and customization of all the Living Lab digital twins. Next, please. Just a brief explanation of how exactly we will do the scoping exercise. So one of the first tasks in the work package is to get the use cases by working with Living Labs, but because there are so many Living Labs, we implemented the train-the-trainer approach. So IMEC has a digital twin design sprint methodology that we developed in previous projects, and we're using that in PRECINCT, so we can train the Living Lab stakeholders in the methodology, and we do it in separate sessions. So we have tooling that supports those activities, but we do 6 different sessions where each Living Lab is trained in that part of the methodology, and then there is like a homework period where the Living Lab executes those exercises and those activities themselves, and then they bring back that output to the next session. And we're now in, well, we've executed on all the sessions, and we're now in the final phase of the definition. So we're finalizing the user story maps, and we're finalizing the architecture that we'll have to provide for those use cases. Next. Thanks. Yeah, that might be a little bit difficult to read. I'm sorry, that's not a problem. So because digital twins themselves are quite a broad concept, and also because there is a lot of knowledge brought into Precinct, tools, software, just insights themselves, we preferred to start from a logical architecture where we identified basically high level blocks that provide for certain business capabilities. So I'm not sure if it's readable for people that are not in the room themselves, but some of these blocks, for example, the asset registry, they provide for a high level business capability like asset governance or managed asset discoverability. And they do that by providing tools and services that support those capabilities. So for asset governance, for example, you will need to have technical data schemas. You will have to refine those data schemas. You will have to do data quality checks, create RDF triples and store them. A capability itself might be provided by a set of components or one component, or it might be that a single component provides multiple capabilities by itself. That's why we use this kind of architectural design methodology, which is based on the C4 modeling methodology, because you can identify at different levels, both at the system level, the context level, and even down to the components themselves, what they consist of, what the different functional interactions are between these components, and it remains until a certain level, it remains relatively agnostic of technology itself. And so the idea would be that we use this design to create blueprints, as was mentioned earlier in Work Package 2, so to deploy digital twins and instantiate them. Next, please. And so talking about those capabilities a bit more, we designed what we call the Precinct capabilities framework, which is based on the Digital Twins Consortium periodic table of capabilities, which Gibrilla showed a screenshot of earlier. We define mostly business capabilities, as I said, which will of course result in certain technical capabilities, but keeping them also always technology agnostic. So we're not talking about Apache Spark, but we're talking about big data querying, for example. As long as the tool itself or the technology itself provides the correct capability or capabilities, it should be possible to use it within your design or your architecture. Also, what this allows is we can group certain capabilities within certain families. As you can see, there's some examples there, but as I talked earlier, there's the asset registry, which provides for asset governance and managed asset discoverability. Well, all of these things are grouped into the asset management family. And you might identify in your use cases or your for your specific digital twin that you will require asset management capabilities, and you might require some of these sub capabilities, but this allows you to see which components provide those and select based on that. And also see what the links or the relationships are between these capabilities. You cannot do managed assets discoverability without having assets under governance, for example. So we don't one of the biggest reasons that we do it like this is because it has the advantage of not pushing the solutions in the direction of a certain vendor tool and create vendor lock-in, but thinking about what exactly you want to accomplish with the digital twin, what business capabilities you would require for that, and then select technologies that provide those. Next. So how will we approach development? Because we are wrapping up the design phase and the user story mapping phase at this time. So it will be an iterative process, and it will start with deploying the core digital, what we call the core digital twin reference prototype. That's where we are right now. We will deploy that in the coming weeks, and we will set it up with a focus on Antwerp. And then we have, in parallel, we will start working on the integration of several of the other components of the PRECINCT platform, such as the AI tools and the serious games and cyber engine self-protection module. We'll also create a library of digital twin components, which you can think of as just a collection of tools and services and technologies that, as I said, provide one or more capabilities on the framework. And it's also very important that we provide enough component spread and overlap so we can make the right choices for each use case or for each living lab. Because there is, of course, differences between the context of the different living labs. There's differences in know-how, technical know-how, differences in the use cases, differences in availability of data, differences in applications that need to be integrated with the digital twin. So it's important that we have a wide enough spread of components that provide even the same capabilities as others, so we can choose and pick what fits best for specific environments. And of course, interoperability then becomes key, because yeah, if you have different if you don't want to fall into a vendor lock-in trap, then these kind of components will either have to be very loosely coupled, which is not ideal, or we will have to comply with certain interoperability standards. And so we'll try to accomplish that by using international and European data standards and formats and standardized interfaces. Some things that come to mind right now is, well, for his data, everybody understands that OGC standards are widely implemented and widely interoperable. But things like CCAN and DCAT AP, and also European standards like NGSI, LD, the whole fireware suite are possible and preferred. Next, please. So I'll wrap up with saying how we intend to then implement the architecture applied to the Living Lab. So we will have the reference architecture, which will create a core digital twin platform with its various integrations. But as I already said, there's lots of differences between the different Living Labs. So I will have to use the tools provided by the PRECINCT ecosystem platform, which WP2 is working on. So we'll have basically that PRECINCT ecosystem platform as a building layer, and we'll create specific instantiations for each living lab based on what their use cases are. We'll have to create different digital twin models for each living lab will provide the tools to construct their own digital twin modules. And as I said, the integrations and AI models will also, of course, be different. Sorry. So final slides. And so the outcome of this work package will be a couple of deliverables, two of them which are reports. First one coming up in July, which is going to be the user story maps and architectural blueprint and design guidelines for digital twins. And then the second one is in March of next year, describing how we created the integration tools to support creation of digital twins in Precinct. And then the final deliverable is the actual software, so the generic digital twin application or blueprint, and the different customizations for all the different living apps. That's my final slide. Thanks.
Thank you so much, David, and thank you for soldiering on there. We really appreciate that. We're now actually on time, which is fantastic. If we have one short question, please go ahead.
Sure. My question is basically, does the digital twin model, how does it compare to the knowledge graph that you'd mentioned? And what's the relationship between those two? Thank you.
Yeah, good question. So indeed, the knowledge graph and the digital twin model, which you can think of as a graph as well, are very similar. But in my view, a knowledge graph is basically an instance of one or multiple interconnected twins. And what we're providing with the Open Digital Twin framework, we're providing capabilities that should allow you to easily map out the used twins and their artifacts, which is the data that the underlying data and the data that they construct, and the functions, which basically are the models. And we need to be able to do that so we can keep the knowledge graph itself under continuous management, and especially keep it under governance, so we can have governance over the kinds of changes that happen on this knowledge graph, because that is very important. The knowledge graph itself maps out all the different relationships, but in a digital twin, you need to be able to describe the kinds of changes that are possible, especially in a situation like we are in with Precinct, where you have multi-stakeholder, multi-use case, multi-twin environments. Mapping out these relationships is a must, and bringing them under governance is even more so a must.
Thank you, David, and thank you for that question. Okay, so we now have time for a very short coffee break. So thank you if you can stay online, if you're joining us online, and everybody here, if we can go for a short break, we'll be back in 10 minutes. Thank you. Hello, everybody. I'm sorry that was such a short coffee break, but to enable us to have time to get to all the sessions and to get to your questions, I'd like to restart the meeting. So I hope you managed to grab yourself a cup of coffee. So in this session, we're going to be talking about the Precinct Living Lab. So there where we are going to be testing and validating the Precinct solutions. Our first speaker is Shirley Delanoy, a researcher at the VIAS Institute, an independent and multidisciplinary Belgian knowledge centre specialised in road safety, mobility and security. She has the role of Work Package 5 leader, and she's also responsible for the Antwerp Living Lab and the transferability demonstrator task. So over to Shirley, thank you.
Hello and good morning, everyone. So let's go ahead. So thank you for joining us for this first Precinct meeting and workshop. So I will be your speaker to introduce you to the WP5 task and objectives. But let's maybe start with who is the VIAS team. So You know me, so that's done. So I'm maybe just a few words. So I'm a researcher and anthropologist, and I joined the VS Institute a bit more than 2 years ago. There is also my colleague, Isabelle Verwey. She is a doctor in criminology, and she's a knowledge group manager, and she understood the role of PRECINCT project manager. She has already been involved in quite a few Horizon 2020 projects, such as Unity and Anita. Let's go within the WIPI5. So what is the role of the WIPI5? I've tried to keep it to the WIPI5 and not to spend too much time on what was already presented this morning by the other WIPI leaders. But regarding the role of the WIPI5, our mission is to orchestrate the Living Lab operation. And we have specific objectives related to this mission. First is to set up and to coordinate the overall planning of the Living Labs that are starting from next month and will take place until the end of the project. Then we have to develop and implement a permanent monitoring learning system and organize a Living Lab of Antwerp, Athens, Bologna, and Ljubljana. We will organize the transferability, that's a difficult word, validation demonstrator to Luxembourg, Ireland, and Uruguay, and develop and implement a measurement and validation system. We have quite a few ambitions within this Living Lab, within this workshop, sorry. First, we need to establish 4 Living Labs in 4 European cities, providing both an experimentation environment and innovation testbed for the PRECINCT infrastructure and services. The second one is to validate the findings and benefits and to prove the transferability into 3 validation demonstrators. And we have identified KPIs to reach, and by those KPIs are to improve by 15% the operational resilience in the Living Lab regions, 15% of improvement against the baseline KPIs, to demonstrate the replication in 4 member states, and to improve by 20% the accuracy of cyber physical threats detection and the resilience index, and by 10% the speed in mitigation and reactions. An overview of the WIPI5. So we have 7 tasks within the WIPI5. You see that we will start at different moments. The task, so the first one already launched, is related to the coordination, the planning, and the monitoring, led by VIAS, and which the major role is to coordinate with the other WIPs the requirements that are addressed to the Living Labs or to the different partners involved in WIPI5. This month, no, actually last month, the task 5.2, led by Connecta, related to the deployment and testing baseline measurement was launched. And this task has the objective to install and technically validate the PRECINCT infrastructure in the Living Labs and to develop the required functionalities for each Living Lab. It will also have to test and monitor the performance and to obtain a baseline measurement of the KPIs. It's a quite short task, so they have a plate full of work. Then we have the Living Labs. So we have the 4 Living Labs. Living Lab 1 and 2 are going to be launched 3 months before the Living Lab 3 and 4. I'm not going to give too much details about those Living Labs because it will be presented right after me. And then we have the transferability validation demonstrator and the measure validation and learning conclusions. Concerning maybe this last one, so it's the measurement, validation, and learning conclusion mission. This task will focus on evaluating the performance of the PRECINCT components in the context of the Living Labs, so the 4 Living Labs, against the user requirement. This task aims to evaluate the proposed framework in terms of user experience and will provide recommendation to end user willing to adopt the PRECINCT solution. This task plays a key role in the commercialization of the strategy. So we are talking about Living Labs, but what actually is a Living Lab? So we have 4 living labs. A living lab, in the contrast of a traditional laboratory, operates in real-life context with a user-centric and multi-method research approach. Within the living lab methodology, the user and the stakeholders from public and private domains are involved and play a key role in the development and innovation research based on the principle of co-creation. These interdisciplinary experts are brought together to develop, deploy, and test technologies in the living lab. This user-centered research methodology, will be used for the development, implementation, monitoring, and evaluation of the PRECINCT ecosystem. And this research methodology is about integrating research and innovation into daily practice and regularly adapting it to its daily practice. By definition, the PRECINCT ecosystem will be developed in close collaboration between the public and private partnerships in the 4 living labs with respect to the user needs. So in other words, it's a dynamic project involving the developers, implementers, and users who are working in close collaboration with each other. Let's jump into the 4 living labs. So you have here the identified countries and cities. I will not give too much detail because, as I said, it's going to be presented just right after this presentation. But maybe just give a few words about Ljubljana here. So the scenario will focus on the threats, on a physical threat, a bomb, and a cyber attack with simultaneous attack to critical parts of the critical infrastructure and on the electricity and communication operators, which provide an important service for business continuity in the transport mobility. For Antwerp, so the scenario of Antwerp is a natural disaster, a flooding, you guess it, because we already talked about it, with cascading effects on water and traffic sea ice. The major stakeholders involved in close collaboration within the living lab is the CPOps, so the multidisciplinary emergency command post, and the energy operator, so electricity and water. Regarding Athens, so this living lab will focus on cyber and physical threats, such as a cyber attack to the airports, a physical attack on fiber optic cables, and an earthquake. John and Makis will develop that later. And for Bologna, it's the focus on the cyber physical attacks on rail and or airport infrastructure, combined with fake news and a cyber attack on the lipidal system, reducing the ability of the CIs and authorities to communicate with the public, and also including the cascading effect on mobilization of first responder services. Living Lab 1 will start earlier, and to ensure that the resilience framework, the infrastructure, and the serious game are tested before to be transferred to the other living labs. Living Lab 2 will also start early, and we set up the digital twin baseline components before transferring to the other living labs. Living Labs 3 and 4 have a number of similar types of CIs, and they have been designed as a twinned living labs. So they will effectively manage together and share threats and vulnerabilities analysis using the serious game approach. Each living lab will establish a CI coordination center, which could also take responsibility for hosting and maintaining the integrated digital twin and serious games. And each living lab has a different path of establish the coordination center, but as it is a key project output, the living lab partner together with different partners will form a task force to produce the 3C blueprints for standardized message exchanges, a generic digital twin architecture, as well as a serious games and a cyber rage-based training. The PRECINCT insight will be transferred into demonstrators to obtain a maximum value. And those demonstrators are Luxembourg, with a focus on energy telecommunication, Ireland, with a focus on transport and energy. And then we have Uruguay, Uruguay, with a focus on water, electricity, and telecom critical infrastructure. The 3 transferability validation demonstrator are involved already within the WP5 to set up the planning and to monitor the activities so that they can transfer insights into their own living labs. As presented by Gabriele this morning, the WP1 related to the specification framework has already been initiated and has made great progress. This part, the specification framework, is a key component to set up a common ground for the whole project. And here I would just give a few words about the digital twin that David presented. So we are going to develop or implement two technologies or tools. I prefer technologies. So the first one is the digital twin. So it will model the current and the future behaviors on territory-based independent CIs, including a variety of conditions and configurations, and to anticipate the threat, to detect the anomalies, and to incentivize optimized command structure. It will also coordinate the response between the CIs and the first responders, which are identified within each living labs. And by consequences, the final objective is to enhance resilience. Within the PRECINCT project, the implementation of the PRECINCT digital twin aims to support decision-making in CI's coordination center. And it will be represented by a CI network topology corresponding to a relevant dependency CI, and will support the resilience methodological framework. Then we have the series game presented by Danielle. Cannot do it as good as he did this morning, but the aim of the series game is to identify vulnerabilities and cascading effects from unanticipated threats, combined or not. And it's an innovative vulnerability assessment tool, particularly adapted to the complex multi-system cascading effects of the living labs. And it will be used as for training purpose, as a form of experimental learning. That's not me. And that employs simulation techniques as a cost-effective alternative to often high-risk and costly real-life activities. And I will end up here. Do you have any question? I hope not. You cannot have questions. No? So I will introduce then Dennis. No, it's Dennis. It's John. John. So I give the floor to John. He's a junior project manager at INLECOM program delivery team and has an active role in the multiple horizon 2020 research project with a task leading role. He holds a master in economics with a major in public policy from the University of Amsterdam and a certificate in project manager with agile specialization from ATH and Tech. Give you the floor. My pleasure.
Greetings, everyone. First of all, thank you very much for attending this meeting, either physically or virtually. As Shirley said in her introduction, I'm John Limax from INLECOM, and I'm going to present you Living Lab 3 of Athens and its operations. INLECOM is the coordinating actor of the Living Lab. Today's agenda of the presentation includes a brief introduction and overview of the Living Lab and its objectives and KPIs. Yeah, apologies. Then we'll move forward to a description of the threat scenarios that they have been developed, as well as we'll focus on the digital twin threat scenario, as well as mockups that have been produced under the steps that David from IMEC has presented in their methodology, as well as some relevant data sets that have been identified in the way forward. PRECINCT Athens Living Lab aim to increase the resilience against cyber physical incidents affecting urban transport in the broader region of Athens. For these reasons, it consists of three relevant CIs, which is Athens International Airport, Attikes Diadromes, which is the main road operator from and to the airport, and Athens Metro, which provide transportation services, again, from to the airport. So all the three relevant CIs operate at the same geographic location. Last but not least, CHEMEA will provide its expertise on security studies, as well as on coordinating with first responders, or on coordinating and communicating with other first responders. So again, as our Living Lab, our aim is to test the PRECINCT platforms and the tools that have been developed or presented previously for increasing their resilience under cyber attacks that may impede the normal operation of critical assets of the aforementioned infrastructures, or due to physical incidents, including an earthquake or a combination of the above one. We'll speak a little bit in more detail about this in the next slide. Now these slides can give us a brief overview of the network of the relevant critical infrastructure, where the blue line is the metro line going from the city center to the airport, as well as a high-level overview of the road sections nearby. Also, I would like to point out that Athens is a city of 4 million people, as well as during the summertime, as some of you may know, airport is pretty busy with tourists. So transportation, increasing transportation resilience, it's a challenging task and very important one, as well as ensuring the safety of passengers or the people using these facilities. Now, a little bit more specific, our objective is to, as Living Lab, is to implement PRECINCT reference framework presented at Work Package 1 for establishing the dependencies between the airport, the road operator, and the metro, as well as their interdependencies and how their service may be affected by energy, water, or others, telecommunication, other telecommunication CIs or operators, as well as use these tools that have been described previously to support the exchange of information for achieving effective and timely communication between the various different responders or the teams that are mobilized during threat scenarios or events. Now, our KPIs we have 4 main KPIs, which relate to reducing the disruption downtime time and having a shorter recovery time back to 90% of variability, increasing the capability of the road system to accommodate unserved metro demand. So people that cannot use the metro will have no other way than using the road, as well as improving response procedures at both at individual level of the CI operators, as well as among the all involved CI operators and stakeholders that are included in some threats events, such as the police or the hospitals nearby. So as a first step, we have we have formulated 7 threat scenarios, identifying a starting point. The first 3 ones focus from the airport, where either a terrorist attack takes place, cyber attacks, or a cyber attack to airport system during an evacuation due to an earthquake, or the lack of availability of fiber optics for airports communications. The second 2 scenarios were focused on metro infrastructures. And again, the first one is related to an terrorist attack to an open air metro station, as well as an energy blackout on the greater region of Athens, of Attica, and how this can affect the operations. Last but not least, another 2 scenarios were developed from our road operator that includes having damages in their infrastructure, damages in their traffic control center, where the monitor of the roads and the traffic conditions in the area take place, as well as roads and adjacent infrastructure damages due to an earthquake. In all the aforementioned scenarios, the critical assets of each organization that are affected have been described, as well as a high-level description of their cascading effects and their propagation to the broader transportation network. Now, our next slide, for the digital twin, we have combined two scenarios, two of the aforementioned scenarios, which we would like to test and simulate through the digital twin. The digital twin scenario starts with a cyber intrusion where an employee inserts a USB and the terrorists take action, can take control of airport system. And apologies, first of all, I would say that this is a flow chart. The yellow boxes depict some processes or steps. The red ones, decision, and the gray ones, rectangles, relevant data sets that are being needed or will be reviewed during that scenario. So going back to it again, there are main three events: a cyber intrusion by an employee, a bomb. This allows the terrorists to go unnoticed and plant a bomb, which near the luggage baggage location. This afterwards go forwards with the terrorists have the ability to make fake announcements for people to go there and maximize their impact, their damages. The bomb unfortunately explodes, and this results to the airport to be evacuated, as well as the incident has been reported and communicated to the other relevant CIs. In order other relevant decisions that will take place during our flow chart is Metro will increase their routes to the airport for helping facilitating its evacuation, as well as the road operator can divert traffic or close lanes for supporting the arrival of the first responders. The situation continues to escalate where a second bomb attack takes place to an open air metro station nearby the airport, as well as the same procedure as previously take place, and the metro station activate its service of bus bridging for evacuating this the station and moving the people, as well as stops its operations as well as this has led us to create some digital twin mockups in order to visualize, in order to understand how this tool can be used under these threat scenarios, as well as test it with our Living Lab stakeholders. As you can see, our initial idea is that, first of all, a digital twin is a virtual representation of the physical world and the assets. So this will be where physical representation of the airport, of the roads nearby, etc. So again, going to a little bit more detail in our mockups. The digital twin should have two modes: the operation mode, where the various CIs, manager or operators can view events, other information such as police station or hospital nearby, some traffic conditions that will be displayed with the layers and the colors down to the right of the screen, where we'll be depicting the people density in some areas or the congestion levels in the roads nearby, as well as its second mode, let's say use, would like to be a simulation mode, where the users could either create new scenarios or simulate past ones, as for example, the relevant CI operator could evaluate how the situation escalate, whether some mitigation actions are taking place, such as enable the bus bridging between stations or selecting different diversion routes during this situation. And in the end of this simulation that will be run as the time legends displays above, would like to have a report that will inform us regarding our KPIs based on the traffic condition and the timing of getting back to the operations. Also, the relevant users of this solution could have the ability to review the scenario, which may help them improve their response timing or lead to new procedures. Last slide for replicating the network through a digital twin. Of course, there is a need for relevant data sets. The first one are statics or related to locations or coordinates of the airport facilities like checking gates, traffic road sensors locations, flight display monitors, the number of available trains to the airport. There's a typo there, apologies, as well as location of toll station, exit ramps, car patrols, etc. As well as there will be more flow sensors or continuous ones regarding the passengers going from the airport to from the metro to the airport, the number of flights, people inside people inside airports after the boarding gates, as well as the number of cars according to toll transaction data. So using all these ones, we're aiming to test or simulate our threat scenarios. And last but not, and our way forward is to continue the interactions with the technical partners, the digital twin and the serious game, for further specifying the needs and requirements, as well as conclude the interdependency and cascading effects graph for our living lab our living labs. And last but not least, our operation starts at month 12, where we're aiming to technically validate the solutions that are being developed under the PRECINCT ecosystem, as well as obtain baseline measurements for our KPIs. Thank you very much for your time. I hope you found them interesting, and I don't know if there is any question that we would like to ask, or okay. Any question regarding our operation? Okay. Thank you very much for your time. And, the floor is yours.
Oh, thank you. Yes, I need this.
But I didn't introduce you.
No, but yes, everyone, it's me again. So I will then introduce you to the Living Lab of Antwerp. So you know me, no introduction needed. So the Living Lab of Antwerp, the threat scenario identified is flooding and disastrous consequences of global warming, with cascading effects on the water sea ice and the impact on the traffic sea ice. So the region of Antwerp and its city in particular are seeing an increasing number of flash floods due to heavy rainfall, and flooding model and rainfall nowcasting and confirming this threat. So to mitigate the effects of flash flooding, the Living Lab methodology will be implemented to develop, implement, monitor, and evaluate the PRECINCT ecosystem. In the case of the Living Lab of Antwerp, this will be just translated in deploying technologies aiming to interconnect the impacted CIs to support the decision-making by the police and the fire department. What is our user story? So we focus on disastrous flooding events in the city of Antwerp, and only in the city of Antwerp, and more precisely in the north of Antwerp, goes by rainburst rainfall lasting for hours. That's something that we quite new in Belgium. The flooding will impact several CI, such as the traffic infrastructure, including the tunnels, and one specific tunnel, the Kennedy Tunnel, the undergrounds, and the other traffic causing obstructions and delay by inundated streets and roads. Traffic obstructions will lead to various effects. So this is where we have the cascading effects. So the authorities will have to handle those effects. Among those effects, we can spot the accidents and injuries caused by the flooding, the revision of the traffic roads, depending on the inundated area, and the establishment of priority roads, way in and way out to the city for emergency services. Another effect of the flooding is can be partial or total energy blackouts, either accidental or intentional, to avoid, for example, to avoid collateral damages. The energy blackouts will create a cascading effects. For example, on the traffic lights are down, provoking major traffic congestion and an immediate response from the police department. We have also an impact on the water pumps in the tunnel. So the extra flooding cannot be extracted. And this will severely impact the traffic roads and streets. Population, panic movements are possible, and citizens will need to be informed. Other crucial CIs, such as hospital, nursing home, schools, kindergarten, can be impacted, and we will need to evacuate them. Public transport can stop, and security issues, for example, an alarm that do not stop working, or we receive false alarm. Concerning the other CIs, so the hospitals, the emergency services, and the chemical industries that we have quite plenty in Antwerp, because this is heaven. So we have a lot of chemical industries in this area. Their daily operation also can be affected directly. For example, there is structural damages on the CI, but so also indirectly, because the staff cannot reach the CI anymore. Additional cascading effects are identified to the energy blackouts of flooding, for example, failure on the pumping stations, blockage of urban drainage system, chemical waste in the sewer system, or damages to car park and basements, so making uncertain the repairs and sealing operation. And then it's even worse for the inhabitants and for the emergency services. So concretely, the scope of the Antwerp Living Lab will be to utilize the precinct reference framework models to establish the dependency map between the CIs in the Antwerp city, and using in the first place the multidisciplinary emergency operational commons post, also called CPOps. Within the Living Lab, 2 technology will be deployed under the coordination of the CPOps. Then we have the series game, which aim to specify the threat scenario, focusing on cascading effects and to identify vulnerabilities and evaluate enhanced resilience, tactical and strategic options. The series games will enable to specify new information sharing process between the key CI operators. And then we have the digital twin, which aim to interconnect the flooding and traffic CIs to support the decision-making by the Antwerp Police and the Fire Department. To reach this goal, a CI coordination center will be created and equipped with the DT, the digital twin, and the physical threat scenario investigate within the digital twin is based on existing emergency plan for each CI and from the CPOps. So we will explore these different scenarios with the series game. The expected output from the Living Labs is first the implementation of the series game and the digital twin through the identification of the cascading effects and interdependency, then enhance insights and early warning system on possible threat and cascading effects, to improve the risk analysis tool and designing response to mitigate the effects such as a threat, and to create an early system warning to benefit the citizen resilience. We will process into 3 major steps. So the first one is the design. We're quite busy with that right now, which in the big lines is to identify the CI impacted by the threat and defining and scope the threat and the cascading effects, but also working on the resilience methodological framework with RDS. We will then customize and select the interdependency models. We will create dependency knowledge graph and define the resilience indicator. The operation phase will focus on the deployment of the precinct infrastructure During this phase, the testing cycle will be implemented to evaluate and measure the selected technologies capabilities in order to quantify the resilience index. And the final phase is to concretize through the validation and learning process. So we will measure and then transfer the learning. The KPIs from Living Lab 2 are defined. So we will enhance understanding of the resilience and methods to enhance it by increasing awareness within the CI network. And we will create a digital twin with associated target improvements. I will not review them, but you can identify that we have quantified the resilience improvement that we have to reach based on the against the baseline measurement. Who are the partners involved? First is PS. So we will coordinate the Living Lab coordination and operation, and we will take responsibility for the CI coordination center. Then we have the Police of Antwerp. We'll take the responsibility for bringing all together the Antwerp region CI, but also bringing all together the disciplines that are involved in the CP Ops, so the fire department, the civil protection, the communication, and the medical emergency services. IMEC, who is designing and implementing the Living Lab digital twin and will integrate the CI models for flooding and traffic prediction. We have KU Leuven, so university from Leuven, who will contribute to the city flooding models on rainfall nowcasting, real-time short-term forecasting, and they will plug these models into the digital twin, including the local rainfall observation with radar data and probabilistic precipitation forecasting scheme with merge and extrapolation nowcast with numerical weather prediction. And the last one is the Waterling, who will provide data on the Living Lab digital twin, will provide data to support the digital twin, providing all the data and data for the sewer system. This is the CP Ops. So here are the major stakeholders involved in the CP Ops. So when we have a threat, these are the different domains that are brought together in one room to take the decision. Depending on the type of threat, the head can be taken by the fire brigades, which is in major of the case, or by the police. We will also include within the Living Lab some external experts from the water management or energy operators. Maybe I'm going to just show you what we have already accomplished for the digital twin task. So Living Lab 2 is having the role of setting up the baseline components for the digital twin before transferring it to the other Living Labs. So with the development of the digital twin is made through the design sprint methodology that David mentioned earlier. So what is a sprint? So we have constituted a sprint team, and we are gathering all the end user needs, and the use case were defined. Then we have given a hierarchy to the use case based on the technical feasibility of those use cases. So for example, do we have the data? Do we have the models? Is it technically feasible to reach or to implement this use case? We had then a user workshop in which the functionalities of the digital twin towards the selected use case are defined with a prospective end user. And finally, we identify the key functionality that are made tangible using mockups and prototypes and custom the digital twin architecture. This approach of the sprint methodology can be summarized in 5 major steps. So first, the focus. So we identify the users and the stakeholders. We define the use case and the data available. Then we analyze, we extrapolate the current issue and practice, the data and models that we are going to be used. And we also have interviews with the stakeholders and the users of the future digital twin. Then we create a storyboard that you can see here, where we identify the design and the functionalities that we will need if we want the end user to use this tool. And we create a mock-up that you can see. Yes, a mock-up where you can, I need to stay in front of the micro. So where you can identify, that's a John already presented, but here you have the map of Antwerp, and then you have different functionalities that you can select. So for example, the police can select the CIs that they want to identify in the flooded area. And for each CI, you have the contacts information to know who to contact, when is it open, and so on and so on. And at the bottom of the screen, you can see that we have this play button where we can see how the situation is going to evolve in the next hours and the probability of the flooding. This is another view where we have identified the roads that are going to be impacted and how it will be concretized in terms of traffic. So what is in red is where you should not go. At the end, we will update the user story mapping. So identifying what are the needs and giving a kind of a priority to the needs. And here you have the flow charts that was already presented for the Living Lab of Antwerp, but here's for Antwerp, where we have all the different interaction between the data and the users. The final goal is to interconnect the flooding and traffic CI to support decision-making by the city, the Antwerp police and the fire department. And I will stop here. Do you have questions? This time you can have. All clear? Great.
Maybe.
Oh yes,
sorry,
go ahead.
Charlie.
Oh, sorry, I didn't see you.
Maybe I have a question about, you were speaking about return on investment as KPIs and econometric models. Are there models you already have, or will they be developed during the project?
That's a good question.
I don't know.
No, we probably have
maybe
already...
you have some drafts, I suppose.
So we actually, for Antwerp, digital twin and, for example, models of rainfall is already provided. So we are already working on existing project and implementing it to the precinct infrastructure. But this needs to be updated based on how the new models that we are building on, and also on the fact that we are only specific to the city center of Antwerp. So we have, let's say, a basis we can use, but we have to create it for the Living Lab of Antwerp very specifically. Now I give the floor to Dennis, who is joining us online. So Dennis is the representative of the Living Lab Ljubljana in Slovenia. He holds a PhD from the Faculty of States and European Studies in Slovenia from 2007. He's a president of the board in the Institute for Cooperative Security Studies, I can make it, and president of Slovenian Association for Cooperative Security. He worked as Slovenian representative in the framework of NATO in the field of intelligence standardization matters, and he serves as an advisor for counterterrorism to the CHOD of Slovenian Armed Force at the period of 2002 and 2010. Dennis, are you on? Yes, hello,
Shirley.
Dennis.
Hello. So thank you very much for my announcement, and of course, thank you for organizing this excellent event. I will shortly present the Living Lab Ljubljana operation. Please, next slide. So regarding the Living Lab Ljubljana, we are talking about the 4 main critical infrastructure providers, which are focused in the multimodal transport, so rail and bus, and we have also the electricity and telecommunication critical infrastructure provider. With this Living Lab, we also have, of course, municipality police of Ljubljana, because all this infrastructure are located in Ljubljana, so we cannot look into the operational picture without operating of municipality of Ljubljana. And of course, we have two institutes which are the supporting partners related to these operational procedures. Please, next slide. To understand the whole environment in Living Lab Ljubljana, we should add also the technical partners, which are important regarding to some important tools which we will develop through the PRECINCT project, and also will be developed and incorporate and tested into the Ljubljana environment. And these supported partners you can see in the bottom part of the slide. Please, next slide. So when we are discussing about the main goal or target in the Living Lab Ljubljana, and also as PRECINCT as a project, of course, we are looking in cascading and interdependencies, influences between the different critical infrastructure. As we saw this morning, we have had a lot of projects regarding the critical infrastructure, but this project were focused pretty much in one sector of critical infrastructures. Here we have multi-applicatory sectors, and to understand the cascading effects and interdependencies is really important. And this is also the case in Living Lab Ljubljana. Because this is only 2 years project, we should be very restricted regarding the framework and the scenarios. For this reason, we decided to have 2 main scenarios, one related to the physical attack and one to the cyber attack. And of course, we also will have some combination of these 2 main threats, but this is the intention and the situation in Living Lab Ljubljana. Please, the next slide. Just to easily understand the situation. So all these critical infrastructure providers are really locally very nearby. So they are not just processually connected with the processes, but also with location, and all major serious attack or some influence could have great impact to all these critical infrastructure providers. And for this reason, it is important to understand where are these interconnections and of course interdependencies between these different players, which are important that this main mobility hub in Ljubljana is operating. Please, the next slide. So this is the future. This is the future state, because now this mobility hub or new railway station in Ljubljana is building, and for us it's really important that all this knowledge and this information from the PRECINCT put also in the process of planning and of course providing this new mobility hub in Ljubljana. And for us it's also very important to understand how these multiple coordination centers, which are inside of each critical infrastructure, now could cooperate and join into the one 3D operational center, and help with the common operational picture to understand better situation and the processes, and of course the influences between these important critical infrastructures. And what is also important that we find and analyze and improve the connections through the national authorities on the city level and also on the national level, because the first responders and all other services such as police and all other important factors are really crucial for the common approach and to better operational activities inside the crisis situation which could occur in such a location or such a mobility hub like in Ljubljana. Please, next slide. So we put on the proposal quite demanding KPIs, which are also numerically stated, and of course these KPIs are not focused just in testing new technologies, but also to understanding the procedures, understanding the new response activities, to understanding each other, to understanding the environment, and of course to interdependencies and cascading effects which could be arise in such a situation of possible attack in such a mobility hub with very nearby located critical infrastructure providers. Next slide, please. So when we prepare to this project, and in the first step of this project, of course, we have made some analysis, especially in a way how to understand how these interdependencies and cascading effects could cause from one infrastructure to operator to another, or this is one-way dependency, or this is the two-way dependency. And I should say that this is a developing operational situation. And I'm sure that in the end of the PRECINCT project, with the help of different tools, serious games, digital twin, and so on, we will better understand and for sure see some other dependency which maybe in the start or the beginning we even not recognize and put some attention. And for this reason, this is so important that in this project we have different critical infrastructure providers from different sectors, because these sectors are really very much differs between each other and with some specifics, and it's important that we understand the broader picture to be much more than resilient and operationally prepared to mitigate some crisis situation or some devastating attacks. Please, next slide. Okay, here we have the digital twin scenario chart. I'm sorry, because this is really not good represented, but this is so complex situation in Living Lab Ljubljana that we have a lot of partners. But what is the most important, that we try to see which information or processes or analyzes could these operational centers, which are already in place in individual critical infrastructure provider, could put in the common 3D operational coordinational center. And with this, we could get the better situational awareness, better joint information, which then could all use to understand not just their own infrastructure, but also the neighborhood infrastructure, which is dependent interdependency relation with this infrastructure. And of course, we also will incorporate here the municipality level, especially in this first responder level, which is important also regarding the communication connection between these coordinational centers. The next slide, please. Now I would like for the end just to show you some example how we want to proceed, especially in the digital twin. Here you can see the situation of the important bridge in Ljubljana, where practically all the main railway connection to the mobility hub in Ljubljana is entering. But this bridge is also important for the traffic transport in Ljubljana, for the bus operator, but not just this. Here we also have some important cables and connections regarding the telecom and the electricity infrastructure. And of course, with this, we try to better understand what could be wrong and what influence we could have if this bridge are attacked in a bomb attack. And of course, we have some collapsing or non-operating this bridge. Please, the next slide. You can see what is the next phase, for example, in the next framework of time. We could, of course, you can see the black lines where the railway traffic immediately will have problems. You can see the part of Ljubljana which will lose the electricity, and of course one part of the telecommunication connections. Please, next slide. And of course this situation will then evolve and get much greater impact regarding the time frame. The next slide, please. You can see that the problems which will cause are not just focusing the railway, the traffic, but also to the electricity and the telecom coverage, and supporting the critical infrastructure and the processes into Ljubljana. The next slide. And of course, with this, we will provide the different indicators which could be focused only in one critical infrastructure. We will, of course, put also here multi-applicative indicators where, like on this slide, all infrastructure and influences are put on. And this is important regarding the common coordinational center, that we understand not just our infrastructure, but also other infrastructures which are interconnected and interdependencies for the operational part regarding the city, the infrastructures, the people, the society, the government offices, and so on. Next slide, please. So what is the way forward? Just, of course, we are the first with Antwerp to start with activities, and we are, of course, in the middle of very demanding operational processes to preparing all activities, which after that will be transferred also to other living labs. And I'm also looking forward for the next collaboration, because we are really good team, and we also already have great impacts and results. So this is pretty much all from my side. Thank you very much, and of course I'm willing to put some answer regarding to your questions if there are.
Okay, is there any questions from the floor or from the online audience? No.
Shirley, thank you very much. I see that.
Thank you, Dennis. So next time I see you in real life, I hope so, because you make the big news. You're not seeing it, but I have the I'm not alone actually.
I am noticed. So
you notice it.
No,
it's not a stomach issue. I'm having a baby. So for those who are so thank you so much, Dennis. Let me introduce you then to Giuseppe Brancacchio. So Giuseppe is from the Institute for Transport and Logistics. He's a junior transport engineer and also interested in the ICT and data analysis, representing the Living Lab for Bologna. He spent many years in Politecnico di Torino, pronounces it well, I hope, both as student and as researcher, tackling different research topics: traffic simulation, transport planning, e-mobility, ADAS system, and road safety. He is currently working on projects related to passenger mobility and logistics, such as SUMPs, sustainable urban mobility plans, and consultancy to public administration. The floor is yours, Giuseppe, and I give you the clicker.
Hello, everybody, and thank you, Shirley, for the presentation. It was complete and covered all my experience. So, first of all, nice to meet you finally in person for the first time, and thank you for your intervention and the intervention that will take place in the following steps of this meeting. So I'm Giuseppe Brancaccio and I'm representing ITL, which is the Institute for Transport and Logistics based in Bologna. And in fact, I will represent the operation of the Living Lab of Bologna, the number 4, which this is a brief index summary of my presentation. I will start by introducing you the members of the Living Lab, because this is one of the crucial aspects of the Living Lab itself. We have Lepida, which is the IT infrastructure and service provider for the region Emilia-Romagna, and it also deal with the ICT development plans. And in particular, these actions are carried on by research and experimentation, and the service are distributed by Lepida itself. So then we have the Bologna Airport, which represents one of the most important critical infrastructure in the region, but also in Italy, since it is the eighth biggest airport in Italy, and of course the major one in the region Emilia-Romagna. Then we have FS Technology, which is part of the Ferrovie dello Stato group, which is the railway company in Italy. And this involvement is important since the Bologna station, as you will see, is one of the most important stations in Italy due to its position. And then we have the Institute for Transport and Logistics, which is the coordinator of the Living Lab and has a lot of experience in the field of, as the name can suggest, transport and logistics, but also with all the relationship with the public administration in the region. Its operation consists in research, consultancy, and so on in the field of transport and logistics. We also have some associated partners, which are I briefly tell what they do. There is TIPER, which is the public transport operator, SRM, the mobility agency in the region. Of course, we have the administrative side represented by the region Emilia-Romagna and the Città Metropolitana of Bologna. We have Marconi Express, which is the people mover that connect the city with the airport. So it's another crucial infrastructure for what concerns the Living Lab activities. And we also have the Port Authority of Ravenna, which is representing the Port of Ravenna, another infrastructure in the region. Now, this map is quite complex, but I will go into detail on the study area in the next slide. This is just because I wanted to show all the infrastructure in Emilia-Romagna and also the one in the surrounding regions. For example, you can see here the cities of Florence, Milan, Venice, and so on, and all the infrastructure such as ports, terminal for rail freight transport, and road network. And for what concerns the study area, you can see that Bologna is surrounded by the road network of the motorways network in Italy, and the airport is just outside of it, while the railway station is in the middle of the city, is very near to the city center, and it is inside the beltway. And this is what the left bottom corner, the picture in the left bottom corner shows. Then you can see also that the track of the people mover, the path of the people mover, which connects the railway station to the airport. And in the base map, you can see the flood hazard map of the study area, because this is one of the treats that we first wanted to consider. Then there you can see that the area is affected by that. You can see also how capillary is the network provided by Lepida. The yellow one is the fiber optic cables, the MAN cables network, and is very capillary into the urbanized area inside the study area. And you can see that the danger is medium or high in proximity of the River Reno, which crosses the area from south to north. And there is a dark blue zone, which is the one. And in terms of critical infrastructure, we can distinguish some punctual infrastructures like the station and the airport. We also have a linear infrastructure like the Marconi Express and the road network, which connects the city with the airport. And we also have a diffused one, which is the telecommunication network managed by Lepida. In particular, Lepida is the main, the network of the telecommunication network is the main object of focus of the Living Lab. And Lepida also manages the R3 station network, which cover other channel of telecommunication. In particular, there are many links between these two networks and other infrastructure. For example, the Marconi Express, which, as I said, is the people mover, has an automatic system of opening gates, which relies on the connection, the Wi-Fi connection provided by Lepida. Moreover, there are the emergency services which operates in the area, which rely on radio communication and other channel of communication, always provided by Lepida. And the other focus of the project is the transport network, which is it's itself made up of different layers, let's say, because there is the Marconi Express, which is the people mover, the road network, which is the main alternative, and of course the main alternative to the Marconi Express, and of course the main alternative for people who reach the airport by car. And there is in particular a crucial node of the road network, which is a roundabout in the proximity of the airport. And at the airport, we have the other important assets to be considered by the Living Lab, which are, for example, the servers, the monitors for containing the information for travelers, and so on. All this stuff relies on the connection provided by Lepida. So Lepida has a crucial role in, and is also the technical partner of the Living Lab, has a crucial role in the whole Living Lab. And on the other boundary of the study area, we have the Bologna railway station, which is, as I said, connected with all the most important cities in Italy due to its barycentric position. And there are both high-speed train and also regional train for people who want to reach the airport, or to for people who come from airport. It connects the Bologna with the surrounding cities. For what concerned the threats and the vulnerabilities of the study area, we identified three main triggers of these the threat scenarios. We have a natural one, which is the windstorm, and so it's an extreme weather event. And the windstorm, in particular, if I go back to the previous one, the wind can affect the operativity of the Marconi Express, because there are some wind speed instrument for the measure of wind speed, which can stop the service of Marconi Express in case of wind with too high speed. So in case Marconi Express won't operate, there is a service provided by tipper, so buses which travel across the road network of the city. And also the travel time between the two alternatives is very different, because Marconi Express has its own infrastructure, so it takes just less than 10 minutes to reach the airport. On the other hand, if we want to move by bus to the airport, it takes more than 20 minutes. So the wind is a trigger the natural trigger, and can cause these problems in terms of airport accessibility, in particular for the people mover. Then we considered a physical damage. So in this case, we supposed, we hypothesized a damage to a man cable of the Lepida network, which can take during road maintenance operation, and can cause cascading effects in the Lepida network, and also in all the infrastructure linked with the Lepida network. So, and then we have also the cyber attack, which can even further complicate the things, because it can coexist with the physical damage. In particular, if it coexists with the physical damage, there will be serious problems, not only for the Lepida network, but also for the R3 station. So also emergency services will be affected by a threat of this kind. The Living Lab 4 starts its activities at month 12, but of course the preparation for this date are crucial. In fact, we participated to all the different work package activities, and in particular to the one related to WUPI1, and we in that context we defined the matrix for the interdependencies, and also the cascading effects, and we defined the three scenarios, which are the one I just told you about. Then we also have participated to WUPI4 activities, and in particular to the train-the-trainer sessions, which gave us the possibility to think about the digital twin, which will be the tool for monitoring all the area, all the network connected one with the other. And in this space, we are finalizing this kind of activity, and also we are working to define the knowledge graph for what concerns the WUPI1. And we will be ready in when the activities related to the serious game will begin. So now I just reported here some pictures in order to make you understand better some of the aspects I just told you about. For example, I was talking about the importance of the Emilia-Romagna region in the Italian, but also in the European context. We do not have only Bologna, since Bologna is connected with all the, due its position, it's connected with all the main infrastructure in Europe. For example, here you can see the map of the TEN-T corridors. For example, Emilia-Romagna is crossed by the Scandinavian Mediterranean one, and also by the Baltic Adriatic one. And you can see here the Marconi Express, which, as I said, is a people mover service connecting the city center with the airport, and its opening gates, which relies on the Lepida network. So I don't know what is happening here with this slide, because the template, there must have been occurred some problem with the template, but it's been a pleasure to tell you resume the activities of the Living Lab to you, and I'm open to eventual questions. So thank you very much.
Thank you very much, Giuseppe. I think we don't have any questions. So thank you to all of our Living Lab leaders and to our Living Lab work package leader for that overview of how we intend to implement the solutions and what we hope to achieve there. So now I'm going to move on to introduce my colleague, Dr. Mark Bennett, a Senior Innovation and Commercialization Consultant at Indicom Commercial Pathways. Mark is an experienced in identifying the commercial value of early stage technologies, and he has managed IP, implemented commercialization strategies, and sourced partners and investors for many new technologies. Most recently, Mark was head of commercialization for a UK university, and he has previously led commercial activities for public and private partnerships and held senior roles. So please, Mark, over to you. Thank you very much.
Thanks, Jenny. So this next session is hopefully going to be a little more interactive. I'm hopefully not going to talk for 20 minutes. You don't want me to talk for 40 minutes, hopefully. So I'm presenting back to you some interim results about business requirements. And you've heard already, discussions from a lot of the Living Labs. Clearly, the project is very user-centric. Shirley used the term user-centric innovation. So this is really what this is about. It's about what we've been doing under work package 1 that Gabriella mentioned earlier. We've been trying to understand the business requirements of the user base. Primarily, we've done that through the medium of a questionnaire. It's gone out to all the users in the consortium. So thanks for everybody for responding on that. We've got responses from absolutely everybody now. We've got responses from outside of the consortium as well, from a number of different types of users. We've been engaging with them, trying to understand the requirements more on, not on a technical level, but a higher operational level, a business level, if you like. And we're feeding that back through the form of a deliverable, but also to you to date, through what we call value propositions and business requirements. And we'd really like to get your feedback today on what we've drafted so far. Does that really make sense for you? So I'm going to talk today about, before we look at business requirements and user requirements, we have to look at who those users are. So we've done some work in terms of segmenting those into user groups. We've drafted some value proposition canvases, which I'll explain a little bit in a minute. And when I go through these, particularly the users in the audience, I would like to get your feedback. Do these fit in with your experiences? And try also to get some idea of the priorities for you. And certainly for I'll go through the draft business requirements. I want you to think about, as I go through those, do they fit with your experience? Should we prioritize any of those? And also very importantly, are we missing any key requirements? So that's what I'm going to talk about. A couple of questions. I don't know how well this is going to work in a hybrid mode, but we'll see. So how many people in the audience would count themselves as users? We obviously some of those in the living labs. In the room, anyone count themselves as a user, a potential user of what Precinct is developing? Possibly a couple in the living labs. Can you see online anyone raising hands?
Yeah, I think a few people are. Yeah, I think we have some representation from critical infrastructure.
Yeah. Okay. And does anyone want to comment on something we a couple of feedback sessions so far? There seems to be perhaps a general lack of understanding of what problems might arise from cascading effects or interdependencies. I mean, clearly those in the living labs, you've gone through this process now with Precinct to try and understand what those would be. So is there anyone from outside the consortium perhaps who can comment on whether those interdependencies, those cascading effects are well understood and what problems might arise from them?
Yeah, so thank you, Päivi Mattila from Laurea University of Applied Sciences and representing EU HypeNet project. So yes, I think the problem statement and the solution and the way forward that you had selected in these scenarios and cascading effects. So everything makes perfectly sense. And I was almost to raise my hand that, yeah, I could be one of the users, but perhaps from the academia point of view. So if this gaming tool would be into use for academia, I think it would give good insights how to develop further innovations, tools, services, and so on. So I was thinking that you don't need to present only critical infrastructure provider practitioner, so to say, but this tool could be, or gaming could be very important for the other users as well.
Absolutely. Yeah, there are multiple levels of users of this, of course. Any comments from anyone online? Okay. I'll move on for the moment. So in terms of segmenting those users, we've drawn this fairly simplistic map. I know it's a very complex sector, very nuanced in many ways. There's many stakeholders perhaps who aren't mentioned here, but for the sake of simplicity, what I'm trying to achieve here, and get those, identify those user segments, this is what I come up with. So on the left-hand side, in the blue, you have the supply side, the private, usually private sector, not always. So your technology suppliers or integrators, strategy consultants, and what you might broadly call security operations centers. Those are operating CIP activities in practice. On the user side, on the right-hand side, really three levels. Level one, where they only really manage their own critical infrastructure or their response sector. Level two, they're starting to coordinate across a small region. And level three, where they may coordinate nationally or multinationally. And I do realize, from what I've heard so far in the sector, level three doesn't really exist so far. Takis has been very clear about that, and something that's perhaps might be an output of the project, a recommendation that level three should exist. So, you know, on the level one, you've got the infrastructure operators who might be from the public domain or private domain, emergency services managers. We've heard about a few of those in the living labs. On level two, city, regional, municipality level coordinators. And obviously on level three, the national multilateral coordination centers. So in terms of segmenting those user groups, because this is something we have to do if we're going to develop a value proposition and understanding of those user groups. First one, broadly terming CI operators, so whether public or private domain. Second one, emergency services managers. And the third one, broadly speaking, regional national response coordinators. So they have a different perspective because they're coordinating across multiple CIs, for instance. So all that makes sense so far? Any questions? I realize this is rather simplistic, but to do what we're trying to do, I have to try and simplify a very complex sector. And finally, the last one is the suppliers themselves. Potentially, particularly those technology integrators, they may be users on behalf of their customers, if you see what I mean. But I won't talk too much about those today. So having understood, you know, who are those segments of the users, try to use the value proposition canvas approach to understand better those customers, the customer profile, and their requirements and needs on it from a business perspective. If you're not familiar with the value proposition canvas, it's just a very visual means of setting out on the right-hand side what the customer profile looks like, what jobs they're trying to do, what would create a gain for them, what is a pain for them, what causes a real problem. On the left-hand side is what you might call the value proposition. It's what the solution is, the product services, and how those aspects of those solutions implement, you know, creating gain or solving problems, solving pains. So in general terms, we start with the user group on the right-hand side, we work backwards, we try to identify what those products and solutions would be and see if there's a match. We're doing this for two reasons in this project. One is purely on looking at the right-hand side to understand the business requirements. Secondly, as and when we develop those products and solutions, we're trying to develop those in a customer-centric perspective so that, you know, when by the end of the project, we'll have something that hopefully those users will need. And when we can think about getting those to market in some way, shape or form. So that is work package 6. Okay. So I'm going to go through each of the user segments. I won't talk about the technology supplier side. When I'm going through these, try to think about which of the pains and gains are the most important to that user group, and also are any missing. The first one is the CI owners or operators, should I say. So these are if you remember, those organizations are only managing their own critical infrastructure, whether that's electricity grid, part of the transport network, communications, for instance. Let's see. So I won't go through the whole of this, but just to give you an idea of a completed full value proposition canvas. I'm going to focus in on the right-hand side for today, thinking firstly about the customer jobs. Obviously, in this context, they need to protect property, staff, and public. They need to maintain operations. They potentially need to minimize damage to other critical infrastructures. They need to reduce the cost of threat mitigation and overall increase their effectiveness in implementing their CIP strategy. So what would constitute a gain for this user group? The ones we've come up with based on the responses so far, things like visualization and modeling of cascading effects and interdependencies, making it much more clear and obvious, maybe in a graphical perspective, the digital twin, serious gaming, what those effects are, and you know, those interdependencies, how they relate. Training comes up a lot. How do you get your staff on board to understand what those critical those cascading effects or dependencies are, and what we might do to mitigate against those threats? Effective strategies, minimizing the impact of those threats. Efficient strategies. So effective might be, minimizing the impact, where efficient might be a more rapid response. I think a few of the Living Labs mentioned rapid response to operations. On the bottom side there, we've got the pains, and these tend to be the most pressing for users. What's really causing them problems at the moment. Bear in mind, I should say, in doing this assessment, a lot of the users who responded, well, the questionnaire is put out to people based on the fact that they know nothing about the solutions that Precinct is going to develop. So this is, think about perhaps pre-Precinct, without knowing what serious gaming might bring us or digital twins might bring us. What are your current problems? Just bear that in mind. A lot of different problems there. As I say, I'd like to get some prioritization if we can. Financial losses, either interruptions or operational or on capital or repair costs. Coordination comes up time and time again. Information sharing, both internally, lots of different departments, perhaps in one operator who need to coordinate together and share information. Environmental damage comes up a lot. Bad PR, press relations. If something goes wrong, you don't want to be up in front of the TV trying to explain what went wrong and why you didn't do anything about it. And this is related to the cascading effects to the extent, what impacts from your critical infrastructure going wrong on other CIs, there's a liability issue there, and vice versa, what the impact of other critical infrastructures on your assets might be. Also comes up quite a lot, unknown vulnerabilities and impacts. A pain is not knowing what's going to happen and what impact it's going to have. It's quite clear. And the last one there is the lengthy service interruptions. Any comments on that one before I move on? Jenny?
Yeah, I think it was sorry, I think it was mentioned by Dennis earlier, and I don't know whether it's covered, but by the point you just mentioned, but I think you don't always know what you don't know. So I think that he was mentioning that one of the things that they're hoping to gain from Precinct is a better understanding of potential issues that they have no idea that could possibly happen to them. So is that something that we're going to be covering in this user, or is it important to be captured by this?
I think it's definitely important to be captured. Clearly, it's those unknowns are a pain that come out pretty much for all the respondents. So, if you can imagine the serious gaming aspect, you're modeling, you're adapting, you're trying to find what those cascading effects might be, then that's really, something that's important as a part of the solution. Any other comments? No? Oh, Päivi.
Yeah, thank you. So I was thinking the legislative aspect. So we do know that there is a new directive proposal at the moment in the table of the Commission. So critical entities resilience directive proposal, and it will give some new tasks for critical infrastructure operators and entities. So perhaps it would be good to highlight here.
Yeah, that's a very good point. Meeting regulations for as they develop. Yeah, that's great. Very good point. Thank you. Okay, I'll move on if there's no more comments. Anything online? Nope. Okay, the next profile is emergency services managers. And as I go through these, you see there's quite a lot of commonality. Slightly different perspective for this user group. So their jobs are coordinating activities in emergency services. Again, they want to keep their assets in their region operating efficiently. They want to increase their effectiveness of their responses. They want to reduce the impact of threats and protect public and property. Quite obvious ones there. On the gain side, I think, they're pretty much exactly the same as before. We're talking about visualization and modeling of those cascading effects, effective training, effective strategies to minimize impact, and rapid response. I think obviously for emergency response, rapid response is the critical one. but that's just me reading between the lines. And in terms of the pains, again, emergency services interruptions, environmental damage. Clearly for this group, loss of life and the health impact is the more important one. The organizational coordination is a real problem. And again, you know, and vulnerabilities and impacts. And perhaps to a less extent, the bad PR is a problem. Any comments on that one? I can see Jenny poised.
Hi, thanks, Mark. Yeah, I think something perhaps that could be included here. It's certainly included for those public sector, other private sector, but for public sector, I think that the financial aspect isn't always sort of mentioned or understood, but all of these emergency services will have budgets and things like that. So, and depending on their service that they give, it can have an impact financially on the budgets that they get. So I don't know whether it's worth including as well.
So that's not the damage to others' assets, it's the impact on their operational costs, essentially. Yeah, you know, it makes sense. Any other comments? Nothing online? Just see. Okay, the final one I'll talk to today is about the regional coordinators. So that level 2 or level 2 and 3, sorry. Coordinating between multiple assets. For them, the jobs, apart from the ones we talked about already, they want to improve the CAP coordination across all those assets and the emergency services as well. Clearly, they want to protect property staff and public, increase the effectiveness, reduce the impacts of threats, and reduce the costs of threat mitigation. So that's related to what you were saying earlier, Jenny. The gains, again, they're common with the other user groups in terms of the pains. Again, a lot of commonality. And I think, yeah, the nothing new to mention there. So those are the customer profiles for those 3 user groups. I won't go through technology suppliers today. If you're interested, it will be in the, for those of you in the partnership, it'll be in the deliverable. Any comments on that particular one? Any users here or count themselves as coordinators? Yeah. Okay, Päivi.
Yeah, thank you. So before I started to work at Laura, I was working at Crisis Management Center, CMC Finland. So I have this first responder background, so to say, or crisis management expert background. So I was thinking that when we are talking about national coordination, also multinational coordination between the member states and so on. So I think it could be highlighted here.
Yeah, the multinational coordination. Yeah, absolutely. Yeah. Particularly given the types of threats we're talking about, terrorist threats, for instance. Yeah, absolutely. Yeah. Okay, any other comments? If not, I'll carry on. So from those, what I've tried to do, as I said, there's 2 purposes behind that value proposition. One is, you know, thinking about the business grants. The other one was thinking about the solution, the product market fit, if you like, and how we get those to market. But from these, what we try to do is extract key business requirements, which which fit into which we can feed back to the technology developers, the product developers, and the consortium to try and make sure that what is developed meets those requirements. When I go through these, I just want to get your feel for whether they fit your experience, which are most important, and again, are only missing. And pre-warning, my perspective on these, and a couple of feedback sessions, they're quite generic, they're quite wide. What I would try to do is really get to which are the most important, any missing, get some prioritization and perhaps some nuances that we can take forward and inform the rest of the technical development teams. So the first set, we took, a lot of the questions in the questionnaire about, what's your use case? Is it more about predictive use, or is it more real-time use? I think that there's a broad spread of answers, but I think initially, at least, if you think about a product roadmap, the first things that I'm seeing that you may need to develop is a predictive tool rather than a hands-on, operational tool. The operational tool, the real-time tool, obviously will be needed, and there's a lot of demand for that, but it may come later. So that's the first business requirement. So it's used in advance, it's for strategy development, prediction, training, etc. Second one, a means by which the users can visualize and understand those vulnerabilities, the cascading effects, etc., and also the effects of the mitigation strategies. Very, very complex network of problems and issues, the assets themselves, the interdependencies, the mitigations. If you can develop a means, which I think Precinct is already doing, of visualizing that and enabling people to easily and quickly understand what's going on, that'll be a great advantage. And allied to that is the increasing understandings of the vulnerabilities across teams and organizations. I think the training aspects of the gaming is going to really help there. Getting people on board, in terms of, understanding the digital twin, the map, the model, and start playing around with that. That's going to really help that coordination and that general understanding. We also had a set of questions about, do you as users develop your own solutions? Do you buy in solutions from private sector, for instance, or it's a combination? And I think the response, generally speaking, at least some of the tools that they use are developed or operated in-house. So any tool has got to be user-friendly. It's going to be easy to adopt. Can't be something that, and maybe this is something much further in terms of the product roadmap, can't be something that, it's very complex to adopt and to use. Okay. Any comments on those? There's another set coming. No comments? I'll complete the set then, and then we can talk about them. Probably fairly obvious. Precinct should be able to identify and mitigate against a wide range of cyber physical threats. Who knows what's coming up? We need to be adaptable to all sorts of different types of threats. Something that came up time and time again is a requirement to get back to operations very, very quickly. As mentioned a couple of times in those Living Lab discussions. Restore normal operations very quickly, either for cost saving or for life saving, health reasons, whatever, to restore normal operations very quickly. You might say that conflicts with the predictive nature that we talked about earlier, but I don't think it does. Even in a predictive sense, if you can, strategically identify those responses which get you back to normal operations quickly, job done. When you get to the real-time operations, you may be also be able to do that in real time as well. Next one, modeling should be focused on certain prioritized areas of impact, not generic impact. So some impacts are more important to some users than others. Health impacts, for instance, returning to operations quickly, the cost impacts. So if we, I think there's certainly talk about this in the design team in terms of identifying which are the priority impacts, and I think there's a little bit of talk about that in the Living Labs as well. Identifying what those impacts are and prioritizing the modeling around those. The next one, cascading effects, interdependencies. Yeah, fairly obviously, the tool should identify the vulnerabilities and identify mitigation responses. And lastly, the solution should improve the currently poor coordination between relevant stakeholders. As I said, pre-warning, rather generic, what you might expect. You could say, yeah, based on that, Precinct is doing the right job and, carry on, pat on the back, etc. But I think we really would like to get more nuanced than that, try and understand which of those are the highest priorities, or are we missing anything? So, having seen all that, any thoughts on prioritization, or very specifically what Precinct should do first? What should, let me put it another way, if Precinct was to do any one thing for you as a user, what would that one thing be? And by the way, if there are not so many users in the audience, anyone who's got experience of engaging with the users, you know, what is your experience? What should we really, really focus on? Lorcan.
Thanks, Mark. Just a slightly related point to, you were wondering what we might be missing here. And just one of the things that struck me was that we're talking a lot about kind of pre-event planning and how we deal with all of that. And it relates to the question, I think, on the serious games from Aka earlier on, is we're looking at the temporal aspects of this as well, but we also want to know how we respond during an event. And that's probably an important thing from the user's perspective as well. And it's quite difficult probably to give a very good picture of that, because without the event, you can't really do it. But we are already simulating how the event occurs as part of the resilience framework. I think there's key aspects of that show that, the user needs to feed information when the event does occur back into their analysis and validate the numbers that come in. So possibly that could be something else from the business requirements perspective that we might need to consider.
Okay, so rather than thinking about preemptive mitigation strategies, it's also about, working on the fly, if you like, to respond rapidly. Yeah, no, exactly. I think that makes sense. Yeah, I think it did come up a lot in the surveys. I wouldn't say it was definitely not 90-10 in terms of predictive, but I think from my perspective, it's more about the product roadmap, if you like. I think technically, as far as I understand, it's easier to do the predictive side of things, the strategic side of things, and you don't work in real time. But eventually, clearly, the users that we've engaged with do need something that is on a real time basis. Yeah, absolutely. Anyone else? Jenny.
Hi, thanks. Yeah, I think perhaps it will probably be very dependent on the geographical area itself as to what is of greater importance and their sophistication level of current communication. So I think probably as a sort of hierarchy of needs kind of approach, understanding what's happening is probably the greatest priority, and then once you understand everything that's happening and the cascading effects and what has a knock-on effect to what, then it's what can we do about it? What tools are in our artillery? What solutions can research projects like PRECINCT provide to plug those gaps? And so I think understanding what's happening first, and then what can we do about it second, perhaps.
No, it's a very good, different way of looking at it, I guess, in that we did figure out that there is a general lack of understanding of what the problems might be. So before developing tools to solve problems you don't know you have, figure out what the problems are, in terms of those, model those scenarios, understand what's going to happen with all these cascading effects, and then you can start to develop the specific tools to mitigate against them. Yeah, there's another comment down the bottom.
Yeah, hello, I'm Stefan from IMEC. We have some experience in working in living labs with cities, mostly smart cities, and using digital twin technology there. So what I see from the user perspective is what they need the most is indeed a kind of way to get these insights structurally. So a kind of standardization also, that they can, if the world is continuously changing, the smart city is continuously changing, new disasters are rapidly evolving, how can they get these insights continuously in a standardized way? That's first thing. And secondly, you were showing user group 4 in the picture, which is the private industry. Yeah. So the private industry is coming with lots of solutions, but if you look at it from a holistic standpoint, you see that it's very difficult to see these isolated industry players, to put them in a kind of strategy that stays consistent. So how can PRECINCT maybe sketch some of that standard approaches there to also include user group 4 inside that ecosystem? I think that's
definitely. I think that's definitely the plan in terms of what we'll be doing in work package 6. It's making the match between the solution suppliers and the user requirements. And interoperability was mentioned a few times this morning. I think part of what you're alluding to is, one supplier has this approach, another supplier has a different approach. They may not work together. and one user might have this supplier's approach, and when they try to communicate, they don't work. So I think that's also important.
Yeah, maybe on that, I think a lot of governments, local governments have budgetary problems. So also coming back to the budget that was simulated in the gameplay, I think it's important because the total cost of ownership of doing that sometimes leads to we will not do it because it's unpayable. And I think that's an important aspect to take into account.
Absolutely, yeah. Any other comments? Anything online? No. I mean, we'll kind of expand upon this in the workshops this afternoon, not purely about the business requirements, but the kind of drivers and enablers for implementing these kind of CIP solutions. From my perspective, what I'm seeing so far, reflecting what Stefan said, there is a market to a certain extent for CIP tools, but what we're talking about on the coordinated level, that market doesn't really exist. The end user doesn't necessarily exist because you don't have those national coordination centers. You don't necessarily, and on the supplier side, you don't have the suppliers who are providing the integrated set of tools or interoperable set of tools. So there's a lot of work to be done in terms of market development as well. But I don't want to preempt what's going forward this afternoon. Any other last questions or comments? If you've got anything you want to chat to me about later on, just come and have a chat and we can make a note of it. No? Okay, thank you.
Thank you very much, Mark. So, I think I've gone forward on your side. I'll just leave it there. Thank you very much. And thank you to all of our speakers this morning and for all of your questions and your interaction. We've heard about the challenge that we're trying to address and the vision that Precinct has and how we're working together as a group to address these challenges. We've heard about the Precinct roadmap. We've talked about some of the blueprints, the concepts that we're thinking of implementing, knowledge graphs, serious games, digital twins, all of these sort of important technologies that we're bringing to bear on these challenges. And we've also heard from the living labs, operationally, what people are planning to do on the ground, the threats that they feel are important to address, and nominally exactly what impact they expect or would like to achieve, the scenarios they're going to be addressing, and how they think that Precinct will be able to help them. We've also just heard about the business requirements and how we can try to address those within the project. So I hope you found it an interesting morning, and thank you for your engagement. So we're now going to have a break for some lunch, after which we'll be coming back to have 2 roundtable discussions and also a presentation from our colleagues from the EU Hibernate project. So we're looking forward to that this afternoon. So please take a break and we will come back at 1:30, and hope you will all stay with us online and participate in the afternoon. So thank you very much, everybody.
Welcome to our afternoon session. Now, hopefully you haven't eaten too much and feeling too sleepy. We really have an exciting panel now. We're actually going to be discussing a lot about the future technical aspects of Precinct. And we have a number of different panelists. First of all, I'll introduce myself, then I'll ask actually each of the panelists to just mention something briefly about themselves. My name is Mark Miller. I'm the Chief Executive of Conceptivity, a Geneva-based think tank in cybersecurity, supply chain security, and critical infrastructure protection. I'm also the Vice Chairman of the European Cybersecurity Organization, the Vice Chairman of the European Organization for Security, and a board member of the Trust in Digital Life organization. So perhaps we start from, please.
So Dorcan Connolly, I'm an associate with Research Driven Solutions. We're leading the resilience methodological framework for Precinct. We also have specific areas looking at sustainability, circular economy, and how we integrate this into resilience of critical infrastructure.
Hi, hi, my name is Stefan Schauer. I'm coming from the AIT, Austrian Institute of Technology. I'm a senior scientist there, and I'm looking into interdependencies of critical infrastructures and cascading effects. And this is also these are the topics that we are bringing into the PRECINCT project and the framework.
Hello, my name is Dr. Daniel McCrum. I'm an assistant professor in the School of Civil Engineering in University College Dublin. And myself and my colleagues here today, we're leading work package 3 in relation to the serious gaming.
Good afternoon. My name is Stefan Lefever. I work for IMEC in Belgium. I'm by education software engineer, and I have 20 years of experience in mainly the telecommunications market. So that domain I know very well as a critical infrastructure, for example. But the last 5 years I've been working at IMEC in smart city landscape, and we are focusing on 2 mainstream technologies which have become very recent these days. Is data space technology. How can we do more level playing data sharing, and digital twins? How can we be translating data more into insights, reliable insights and sovereign insights? That's our main technology. And we apply that in 3 major domains. It's public health, it's mobility and logistics, and sustainable environments.
And online, we also have Gabriele.
Yeah,
Please introduce yourself. Thank you.
Good afternoon. My name is Gabriele Giunta from Engineering Informatica. Since I worked from 2002. Well, my role in the engineering research and development lab is I'm the head of the unit of smart transportation infrastructure, which is mainly focusing on the aspect of the security and resilience of critical infrastructures, including also the transportation and the logistic aspects. In the last few years, I was involved in several research projects with the role of the technical manager and project coordinator dealing with the critical infrastructure protection. And our main work is actually to provide innovative solutions that are going to consider the systemic aspect of the critical infrastructure. So we are mainly focusing on the analysis of the relevant threats, cyber physical and joint the cyber physical threats, in order to create a realistic and effective situational picture, just to be so as to be processed, integrating several information coming from different sources and to be visualized to the end users in order to make an effective decision.
Thank you very much, Gabriele. Let me start just with just to say that the whole idea is that this session will be interactive. So questions from the floor are welcome. We do have some questions that have already been prepared, of course, and as well questions from the audience online are also welcome. And the idea is that the panelists may interact not just with answering the question, but may interact with one another as well. Let me just start this off with a question to Lorcan. Risk assessment has been universally accepted as a tool for decades to analyze impacts of natural and man-made threats to critical infrastructure. What are the benefits of the PRECINCT resilience methodological framework over the traditional advanced risk assessment approaches?
Sure, yeah, so it's an important question, I think, Mark, and apologies, yeah, for methodological, it's a bit of a mouthful, but we'll get across that. So I guess the answer really lies in some of the business requirements that Mark touched on earlier. Risk assessment is still there, risk analysis is still there, people still use it. Obviously, it's still an extremely important tool because in the first instance, it's what we're concerned about. But the PRECINCT framework really looks at risk from a service provision perspective, and that's what it allows us to do. It allows us to quantify in monetary terms across different CIs how the impact of these hazards propagates across the system. So there's a lot of discussion on interoperability earlier on and how we can coordinate across different infrastructures. And the answer really is in resilience, because it gives us that facility to consider different types of service, how they're impacted by the hazard, and how we can combine them together. But also crucially, it allows us to look at the temporal aspects, which again we touched on this morning. So we need to be able to consider how long these impacts last in order to quantify the actual downsides of them. And likewise, I guess, crucially again, in terms of resilience, it allows us to build in aspects not just relating to the physical nature of the infrastructure system. We look at the organization as well. So the users, in some respects, are an input to the resilience framework. They're end users, but also the way that the users operate their system in turn impacts on the resilience of the system. So that is, again, I guess, a key reason why we're looking at resilience in PRECINCT.
It leads me to another thought process, which is, how does this end up, for example, in the realm of the digital twins? How are the digital twins used to simulate the vulnerabilities and to address the issues that have come out of this new approach toward looking at risk assessment? Perhaps, Stefan, you can speak a bit about the simulation and the digital twins and how this is tested and validated to support the resilience of critical infrastructure. And how does the digital twin information management framework actually support this? And can resilient digital twins actually play a role?
Yeah, thank you, Mark. I think Lorcan already mentioned the magic word interoperability. If we look at the critical infrastructure resilience as a kind of the front end of PRECINCT, I think we have a back end, which is the digital technology that handles all the data and the compute that is needed. And on that level, there is a level of resilience needed. I think business requirement 1, if I'm not mistaken, proposed by Mark, was about the digital twins, and PRECINCT should enable strategic decision taking. I think that's the first level of business requirement that's needed, and the interoperability to be able to do that, to be able to use data in a kind of uniform way to model this, the impacts of changes to critical infrastructure towards eventually the citizens. Now, in the back of that, there is a lot of technology used, I think also introduced in Work Package 2, that needs some abstraction. I think the TOSCA framework was mentioned for abstraction, but there is more to that, because how we look at digital twins is that they are kind of aggregates to rule smart data. I think the European Commission has also a big mission on smart data. And digital twins are all about what is smart data and how do I define the meanings of the data. Because if you want to use data in a kind of consistent and sovereign way, and you want to make the use of that data accountable, you need to be able to handle that in a consistent way. I think David this morning already mentioned asset registries and case scenario managers. I think they're all very important components of digital twins that need to make sure that that ecosystem of, let's say, digital twin models, digital twin data, and gameplay can come together in a more scalable way. Now, when it comes to resilient digital twins, I would like to take again the business requirement number 1, which is about how could we foresee in future technical aspects of digital twins, how could we foresee already that now maybe the first level is to make it a strategic tool, but how could it become an operational tool? Because the real definition of a digital twin is that it is a bidirectional tool. You get insights, you get data from your physical assets, and you can interact also automatically with your physical asset from your virtual asset. Meaning that, for example, your fire department could have a business process coupled to your digital replica. But for that, your digital replica needs to be resilient. I want to give an example of AI. I think AI these days is used a lot because modeling the complexity has become a real problem because it's so complex. Now, if you look at AI, it's very good when you have lots of data that you can train on that is consistent, that the behavior comes out. But if you look at disruptions, and which is in PRECINCT, of course, the case, it's difficult to have a lot of data. So if you would couple your digital twin eventually to your physical object, being the city or the region, and you want to trust that, you need a kind of augmented intelligence. You need to be able to couple human intelligence to the intelligence that these models and this compute brings. And doing that needs a lot of digital twin power under the hood, meaning you need to understand, the humans need to understand how this decision taking took place. If there are changes in data, which is continuously happening in critical infrastructure systems that are fed by, for example, IoT data, if there are changes and these changes have a quality issue or could lead to a quality issue, humans have to be able to control that. And that transparency of bringing, for example, AI models more transparently into the ecosystem of cascading models to reflect critical infrastructures is how we see the value of digital twins. Because that periodic table that was mentioned this morning, if you look at it in detail, it contains all the information technology assets that I know of. So you have to choose what is important, and for us, making it accountable, not only to strategic decision takers, but also to decision processes in the end, is one of the things where digital twins can bring resilience to human and machine interaction.
Thank you very much, Stefan. Something you mentioned, Stefan, leads me to think about a question for Gabrielle. In recent years, and you've just mentioned this, Stefan, the complexity of cyber and physical threats is increasing rapidly. And as a result of the ongoing digital transformation of the critical infrastructure operators. Gabrielle, what are the main technological challenges in critical infrastructure security and protection that we're going to address in PRECINCT? Be interesting to have a bit more of a summary of that for everyone here.
Yeah, thank you, Mark, for your question. Before answering, I would like to say a few words about the landscape where we are working on. The critical infrastructures are the modern critical infrastructure have to be considered as a sort of large scale cyber physical system. In some cases, like the case of PRECINCT, the system of systems. So it is a very complex domain where we have to operate, and we have to consider that when we are going to design, to implement, and to make operative the existing hardware systems of solutions for critical infrastructure protection, the boundaries between the physical security and the cyber security are still blurred. Meaning that when we are going to consider emergency systems for critical infrastructure protection security, we have to consider such kind of systems as a sort of integrated approach that have to emphasize that between the cyber security and the physical security techniques, there is a strong relationship. This is something that, to my view, is quite new. And this is why there is a strong need for a new type of integrated security solutions, like security intelligence, cyber intelligence solutions, that we have to provide in PRECINCT as a main asset. When we talk about cyber and physical threats, is something that was addressed in most of the last critical infrastructure protection research projects funded by the European Commission. So what the European Commission asked us in the last 10 years was actually to have a strong look to the different critical domains, the cyber part and the physical part, but now we are focusing on such kind of joint domain where the cyber and the physical threats are most of the case a combination of threats, in some cases hybrid threats also explained by PAVI in EUHiveNet project. What we are going to address in PRECINCT is to provide innovative solutions and technologies for the integration of an integrated modeling of cyber and physical systems based on resilience indicators, based on data-driven approaches, including big data analytics and big data infrastructural services. So, and most of the case also based on artificial intelligence tool sets. One of the peculiarity in that we are going to address in PRECINCT is actually to consider the digital twin. As also said by Stefan, the digital twin is a key challenging point that we can exploit in order to make our critical infrastructure much more integrated in the process, because in most of the case it is not possible to go through the critical infrastructure to have a real data from the critical infrastructure, or to have a strong interaction with the operative systems and procedures. Most of the case when we talk and we work with the critical infrastructure operators, the first thing that they say is, yes, you can work with us, but you don't have to consider our technical solution. We cannot provide you any kind of data because it is an operative infrastructure. So if we are stop working, there is a big issue. This is why they are critical infrastructure. And in such case, one of the solution is consistent having the digital twin. As I said by Stefan, digital twin is the scope of the digital twin is dual. We have actually the digital twin for simulating real-time data coming from the infrastructure, the real infrastructure, while we are using the digital twin. So the data are real, but are not coming directly from the infrastructure, but by the digital twin. And such kind of data are relevant in order to make a lot of effort in the big data analytics, in integration of existing systems, and on the other side, having also the possibility to test the hardware solution in the digital twin. It is also possible to make some effective simulations. In most of the cases, we can have a concrete result of after the simulation of our solution in order to see if we are providing the right solution at the right time, or if we need to tailor something in order to make much more effective to mitigate some kind of threats. Another important aspect of PRECINCT is, besides the digital twin, is what we have mentioned today during the morning session. And actually, it consists on two elements. One is related to the interdependencies and cascading effects. In my experience, the interdependencies and the cascading effect have been addressed as a sort of extension of the traditional the work to be done within the research project. So let's see if it is possible to look outside the critical infrastructure, to look at some kind of interdependencies, and to provide some kind of formal or hypothetical approach for interdependencies or for evaluating cascading effects. It is something that normally is a sort of extra effort. In most of the cases, it is something that was never included into the research projects. While in PRECINCT, it's exactly in the middle of the scene. We are focusing exactly on the interdependencies because our main infrastructure is a sort of a virtual network of different infrastructures that are strongly interdependent in each other, and where we have to look at the cascading effect of our primary aim. It is not a secondary scope, it is not an extra effort, it is our main mission. So here where PRECINCT is going to contribute, considering that the majority of the research projects have already provided a concrete solution for each individual infrastructure. Now we are moving towards a new kind of view. The critical infrastructure per se is already secure because we can implement tons of solutions, number of solutions that have been deployed and experimented in the last 10 years. But anyone has say something about the network and infrastructure, the critical infrastructure. In PRECINCT, we have 4 different living labs. And in the living labs, we have several critical infrastructure interconnected each other, is where we have to provide the concrete solution to them. They already have solution for the single infrastructure. Now they would like to know how I have to operate in case of interconnected the critical infrastructure. And this is where PRECINCT is strongly focused. The
Perfect.
third point, oh, sorry.
Sorry, please continue. Please continue.
No, the last point is related to the serious game, but it was also explicitly described during the morning presentation, and probably there is also David that wants to say something during this roundtable. Sorry if I
No problem, no problem. Thank you very much, Gabriel, for your quite extensive explanation. One of the areas that stood out for me was your comment on cascading effects and interdependencies, and that leads me to ask the question to Stefan Schauer about the interdependencies graph and the cascading effects simulation. How is that integrated in what we're doing in PRECINCT? And also, perhaps you can talk a bit about how this is all part of the digital twins and how the digital twins are actually used in analyzing that as well. Stefan.
Thank you for the question. The interdependency graphs, so the dependencies, the interrelations between the critical infrastructures, as Gabriela just said, but also as we've heard from the other participants here, is one of the core aspects of the project of PRECINCT. So what we want to understand and what we want to also provide to the end users is this integrated overview on how the critical infrastructures of the living labs or of a city in general, how they are depending on each other, how they are related to each other. And with the tool of the interdependency graph, we are taking information coming from the experts, from the living labs, so the operators of the critical infrastructures, and build this, let's say, abstracted graph with information about how each and how the individual critical systems, critical entities, how they react to a specific incident. So in the morning, we heard about the knowledge graph. So where we have this information on the effects, the individual effects of a specific incident. And by connecting the dots, by connecting the critical systems, we can then build up also an overview on how the entire system reacts to a specific incident. And this then brings us to the cascading effect simulation. So from that point on, we can see how the change of, let's say, the functionality of one critical system affects also the operation of the other critical systems. And because you were relating to the digital twins, on the one hand, this is then integrated into the digital twin. So the entire digital twin takes that information to showcase the cascading effects over the individual infrastructures. And this is also one aspect that is fed into the serious game. As we've heard before lunch break, serious game is taking information on the cascading effect, showcasing it to the end users to train them.
Yeah, maybe I could follow up on that. I mean,
please.
So very much so, and I was kind of struck when you put all the Living Lab partners together, based on what everyone has said here, and they highlighted, you know, what are they getting from PRECINCT, and a common theme was definitely this, you know, how are the, you know, we have a flood, and what happens elsewhere, we don't know, is the answer, you know. So the serious game, following on from what Stefan has said, we believe like there's two aspects to it. One is a vulnerability assessment tool, and following on through the resilience scores, you can do that. But it's a way of visualizing and understanding something that's quite complex. So what everybody else is doing will feed into the game. So we see the game to be a really useful tool for training, you know. So you could imagine that you have an event. So in the living labs, we're only doing really one scenario, one major scenario in each living lab. But you could imagine in the future where there's multiple scenarios are built into the game, and you can repeatedly play this game. You can repeatedly make mistakes. You don't have to make these mistakes in the real world, you know. You can decide on what you're, you know, how you're going to update the, or, you know, do we fix the tunnel in Antwerp, in the Kennedy tunnel, or what do we do? Okay, so that would follow on very much from, and I was very much struck when the Living Lab partners, they put their presentations all together today, and they said what their KPIs and what they want to get from Precinct. It came up over and over again, you know, when they gave their examples. So we would see the serious game as being a tool to achieve that, you know.
Maybe a question for Stefan and Gabriel. You were talking about knowledge graphs and cyber and physical threats and security threats. So what I'm seeing these days is that the, how do you call that? The attack surface for cyber for cyber attacks is becoming rapidly much more bigger. Huh? For example, you could have a watering system where there are pumps and they are controlled by humans, but tomorrow they are controlled just by machines and by just internet technology. We see projects in Flanders where ships don't have any captain anymore. They are just steered by. So lots of new threats are coming in. So I can assume that this also the knowledge graph can change frequently. How do I, as a user, as a city, or how can I manage these changes in a way that this becomes traceable and that this becomes an asset that I can manage? Do you have any vision on that?
Maybe to get on that from the perspective of the critical infrastructure interdependency graph, we are considering the individual threats that are coming from the outside, but we are, let's say, more focusing on the effects that those threats have. So as you said, a ship can be steered by a captain or an AI autonomous driving whatever machine. A pump could be operated by the maintenance guy or by some intelligent algorithm. The threats that either the algorithm or the person is corrupted or wants to do some harm to the pump, the effect might be the same. So we have a broad threat surface, but the effects of the threat might be a little bit smaller and also more manageable. So we can deal with those effects of particular threats and then start from that one with simulating the cascading effects.
So basically what you say is that you abstract away from that and you push in, for example, the operational status, and the risk changes if it's steered by the electronic highway or by a human. It's a different risk that you put into the knowledge graph and that you can manage. And so that changes less frequently than all the operational stuff around it.
Exactly, exactly.
And maybe coming back to Gabriel this morning, you said something about, I think it was you, about the quantification of the resilience. Does that have an impact on that? If changes to the knowledge graph, it probably changes the quantification of the resilience. How does that work?
Yeah, Stefan, just to provide my personal feeling about how to deal with such kind of continuous changing and in terms of cyber and physical threats, and also how to deal with such attack surface that is coming to become bigger and bigger every day. My opinion is that one of the winning solution is something that is related to the preparedness phase. So to be prepared once the attack strikes. What does it mean to be prepared? What does it mean having an effective preparedness? Actually, it is part of the work that we have considered and we are considering in the work package 1. Once we are going to have an effective risk assessment, We are going to consider all the different vulnerabilities, even in such kind of complex critical infrastructures, because are interconnected each other, and also have an effective evaluation of the resilience. From one side, we are very aware about which kind of threats we have to mitigate, which kind of threats we have to protect against our infrastructures. And on the other side, we are much more aware about how we are resilient against such kind of threats. And the work done by RDS with the resilience framework is exactly what I have mentioned this morning in my presentation. So having a quantitative and qualitative analysis of these such kind of resilience indicators, it is possible to duty analyze the overall critical infrastructure from different aspects, because we are not just talking about the technological aspects. We are also talking about the societal and the economical and the organizational aspects. And once we are going to make such kind of effective evaluation of how much resilient is our infrastructure, we are well aware about how much we are prepared against such kind of physical and cyber threats. It is something that has to be changed again every time, because respect the past, the risk assessment is going to be done in a different way, a different approach. And it has to consider also the resilience assessment. So this is something that has to be also considered as a new way to address such kind of new threats. So having a better understanding of our resilience and our resilience indicators against the vulnerabilities of our infrastructures.
Yeah, and I might be able to add to that a bit, Stefan. So Gabriele has given a very good overview of how the framework can consider this kind of changing environment. And I think it comes back again to the business requirements. We mentioned that a number of our business requirements deal with the pre-disaster phase, the preparation phase, and that's where I think we all agree the serious games tool is extremely useful in that area. But likewise, it has to be part of the framework that you always come back and you reassess, you reevaluate if your systems adequately describe the threat, and if they have taken account of recent changes in the system. So I think that would hopefully be something that would easily be built upon once you have the framework in place to assess the resilience quantitatively.
That brings me to a question about the serious games concept. Is it something that of course is going to be evolving over time, meaning that the serious game has to have additional parameters, additional as the say the threat surface changes, as the parameters change, will the serious games approach be adjusted and adapted to that?
Yeah, it's a very good question, and I suppose, and actually myself and Stefan talked a little bit about standardization of an approach to the threat sources. You know, so in PRECINCT, you'll have seen that there's specific threat sources to each individual living lab, and they're the ones we're going to consider within the 2-year duration of this project. But maybe a standardized approach to these threat sources that can be applied, you know, between the digital twin and the serious game would be an excellent approach for that. And actually, until myself and Stefan had met today, we hadn't really discussed this, you know, so it's quite an appropriate question. But hopefully you'll see from the serious game is there's flexibility in there, you know. You know, we're going to be meeting with the Living Lab partners soon, and we're going to learn a lot about that in terms of. But I would come back to what the other guys in the panel have mentioned, is that there's also flexibility in their approach as well that feeds the information into the serious game. So there's flexibility in terms of the interdependency graph and in terms of how you deal with resilience. So I suppose the question is, you know, where does that change take place if you've got new threats? And it probably changes across the platform potentially, you know, if that answers the question, hopefully.
Sure. I guess another area that I would think about also is, where are these technologies headed? Where are these technical aspects headed? I mean, are we going to reach the end with everything in Precinct, or are we're really just setting the base for what's going to happen in the future? And is it a situation where we're on the cutting edge, on the bleeding edge, or are we already starting to have some of the technologies be more mature at this point? It'd be interesting just to know your thought process, and what are the technologies that you see that are going to come out of this, in addition to, of course, we're doing a lot of things in Precinct, but you know, thinking outside the box a bit. Any comments on this?
Yeah, maybe to say something about digital twins. If you would look at the Gartner hype cycles, they would be very much on top, which means that everybody expects everything from digital twins. So we are rapidly going down into the disillusionment zone, or how do they call that, where you will have to prove that what is the real value of that. So I think these projects like Precinct, they allow to come to the real, to get out of the inflated expectations and to prove the real value of that. So in that sense, these projects contribute really also to getting data insights much more applicable with the right technology. That's my opinion about it.
I would say in relation to the serious games, so I mean, serious gaming has been around for a few years, and as a concept, it's not new, but I would say the future technologies will certainly be the mining of the gameplay that we do within Precinct will provide huge novelty and huge directions forward. And I would say we don't even have some of the answers quite yet, you know, so it's quite an exciting space in that respect.
So from my perspective, I also feel what you said, Stefan, that having the digital twin as one of the core parts in Precinct is what makes the how do you say, the creativity, the new part in Precinct. And I think that at the end of the project, we won't be at the end of the development. So there is a lot of still more to do, more to research and so on. Particularly when looking at how we could use the digital twins. On the one hand, building digital twins from the concepts that we are developing, like the interdependency graph, the resilience measure, and also using it in the serious games. But also maybe later on using digital twins provided maybe by critical infrastructure operators as an input to the interdependency graph, to have a better understanding and a better picture of how the critical infrastructures, the elements, how they work, and how they can evolve over time. So this would be something that I would see for the future.
Yeah, and then I guess just adding a slight addition to that, the concept of integrating all of these tools together within a precinct that considers multimodal infrastructure, considers multiple hazards, is already quite innovative, is quite a step into the future. But I think a logical step as well goes back to the different levels of the end users that we can apply this to. So, you know, we had our first level, which would be the individual infrastructure owners. Then the logical next step is you move to regional authorities who can integrate that information together. And that's where we're at really in Precinct. And again, this has been reflected in the Commission's focus. I think in recent years, they've moved more of a focus onto the regional authorities and how they can apply the tools from projects like this. But then the final step and the future step, I guess, is how this can develop into an international approach, integrating things together. And I guess the very first step in that regard is at least have different precincts using the same methodology, doing it in the same way, and then maybe in the future we can develop it into one system.
Hijacking on that, I think when you talk about is it cutting edge or bleeding edge, I think what you see in the ecosystem is that these projects make digital twins tangible. For example, we see that there are lots of national digital twins being being started. You have the UK National Digital Twin. In Sweden, there is an initiative. The Netherlands, Luxembourg has its National Digital Twin. So everybody starts to realize we need infrastructure to be able to to make these projects like PRECINCT in the end operationally feasible. But that they don't solve the problem of critical infrastructure and the impacts of that. So that's where I think we could align with these initiatives that are there, use that technology, but apply it on the real usage in that field. I think that's the interesting thing.
Yeah, I would like to have also another important aspect besides what we are saying now is related to the reusability of the existing solutions. Existing solutions already in place and the several critical infrastructures that we are considering as our main test bed where we can demonstrate that our solutions are quite innovative and useful. Or existing solutions coming from already ended research projects in the same domain, the critical infrastructure domain. This is also something evident in the approach that we are using in PRECINCT, because it is clear that we would like to start from several existing solutions from the already ended the research project, more than, if I remember, 10 existing concrete solutions that we would like to reuse in our integrated ecosystem platform as a sort of test bed where we can demonstrate what is going to be mitigate according to the existing cyber and physical threats. And another important aspect is that we have to finalize everything in a very short time. The European Commission wants to have everything when the call was launched, it was 24 months. So having something concretely to be used and to be exploitable into the relevant markets only after 24 months is a quite challenging activities. So this is why it is not possible to start from the scratch. It is not possible to reinvent the wheel. We have to start for sure for something that was already demonstrated in our relevant pilot that might be easily integrated in our ecosystem platform. And this is where we have to work on in order to have an easy integration of the existing work.
Yes, please, from the floor.
Yes, I have a question regarding the importance of the digital twin. So as you explained, Stefan, isn't that the digital twin will become another critical infrastructure, and how you envision to protect it?
That's a very good reflection. I think any information technology infrastructure will become a critical infrastructure in the end. So if you have, for example, a national digital twin infrastructure, you will have to foresee the same cyber attacks on that system as you do on another system. So that could be indeed, the digital twin could be a critical infrastructure that PRECINCT can address. How to protect that? There are lots of ways to protect information technology. But I'm not an expert in all of these ways to protect that. But your remark is fully correct, I think. Yes.
So for the other panelists, I think is it not an interesting aspect to put in the risk analysis and the knowledge graphs when the digital infrastructure fails or is compromised? What would happen then? What is the cascading effect for the other critical infrastructure that depends on the digital twin? And when it failed, then what are the cascading effects? So
yeah, I think I think that's a good remark. Now, maybe to come back to your first question, I think one of the ways that we see how a digital twin can be protected is by its distributed and federated nature from the beginning. So if we talk, for example, about asset registries, which are going to store and export data from semantic data, for example. It should be a distributed system. So it should be interoperable, but you should be able to let different twins that cooperate in that framework be able to express their, so that if something falls out, that it's not damaging the full system. So distribution and federation is, for me, one of the keys, because it's much easier to apply backup technology and shortcutting critical paths, is that if you have a distributed system by nature, and that has lots of implications. But indeed, that is just a solution, but the risk should be mitigated indeed, should be expressed, yes.
Just to comment on that, I think it's very important to ask that question in the first place, to be aware that by building such a digital twin, you're basically building a vulnerable system itself. If you will, you're building kind of a playground for an attacker who can then just use it as a serious game and try with the digital twin where to create the most effect. So being aware that this is possible is, I think, the first step. As Stefan said, there are many technical ways to protect it, but still, we would need to consider even maybe not the digital twin itself being attacked, but maybe the information. So when it comes to adversarial examples and something like this, so if the digital twin is learning from corrupted data, then maybe the digital twin itself, although it's not attacked, it's not representing the reality. And this again, and maybe I'm going a little bit ahead to the next presentation from Päivi. This would also go a little bit into the hybrid warfare, hybrid attacks path thinking in that level. Yeah.
Are there any other questions from the participants here? Yes, please.
Hi, everyone. I have a question from the Living Labs perspective. We're talking about the cascading, the interdependency graphs, the cascading effects, the digital twins. Are these all going to be incorporated in the digital twin? Are they going to be offered to the CI operators as a different service? How our Living Lab users in the end will reap their benefits through the PRECINCT platform, the digital twin? I see some overlap on the solutions. Yeah. Or what's the difference between the platform and the digital twin that could the difference that they will offer?
Exactly. So I'd like to start from the point of view of the interdependency graph. As I mentioned in the beginning, the interdependency graph will be built in cooperation and based on the knowledge from the Living Lab, from the operators that are working together in the Living Lab. So by having some workshops online, offline, whatever, we would get an overview and build based on the communication, build the interdependency graph. And I think this per se would be a first result that could then be given to the critical infrastructure operators. Just although they may know where the dependencies lie, individually, bilaterally, maybe, having an overall picture of the interdependencies within one Living Lab could be a first gain that is coming from the project. And as we've discussed earlier, this information is then going into the other technologies, like digital twin being built based on the interdependency graph. Same for the serious games. So in the framework, you would find also let's say the picture of the interdependency graph, but then could also work with the effects from the simulation, for example.
Yeah, I think it's a very good question, because we get these questions nearly daily when we interact with cities, for example. They say, yeah, we have a smart city data platform. Why do we need a digital twin? I see data lake house, I see blah, blah, blah. So I think the key thing is for a Living Lab is to detect the real requirements and to think as an answer in capabilities, not in information technology, but what do we need as capabilities to be able to meet these requirements? And these capabilities are mostly functional business-wise, but they have a technical counterpart. And it's at the end, it's choosing this big table, periodic table of technology will give you some technology that fits the business requirements. But there is no technological answer to any living lab question. That's my vision on that.
And I might be able to just add slightly on it. I mean, the interesting thing that I've found from this project is that I think each of the experts in their individual areas is trying to capitalize on what everybody else is doing, and that's quite good. It means that we're developing a much better product. But we find that, you know, the resilience framework, we see the cascading effects as an integral part of that. We want to use it to develop a better indication of resilience. Likewise, Serious Game is going to use the cascading effects not only to calculate, but also to demonstrate, as Stefan just mentioned, to demonstrate to the owners how the interdependencies work and how it affects the resilience overall. So really, I think, in short, the answer is probably that the Precinct offering is the entirety of these tools. They each feed off each other, but they're all a different part of the overall goal to enhance resilience.
If I might on what he said is that practically, for example, where are those tools are going to be deployed? For example, are we going to use Amazon, a cloud provider, and put there the digital twin, the Serious Game, the big data infrastructure for a living lab? Or in Athens, where are they going to practically deploy those tools, and which tools are they going to be used? I think this is maybe one aspect of the question. How the tools are going to be deployed inside a given environment? I mean, by environment, are we going to provide one for project, or specifically, or combine them in a hybrid? So this is an open question, I think, just try to clarify.
Yeah, if I may add something about what Gibrila is saying in terms of deployment, I would like also to emphasize that before having the deployment in PRECINCT, we have an activity that is named like instantiation. It's something that allows to end users to having an overall view of the PRECINCT ecosystem platform, which where the digital twin and the Serious Game are part of it, just to have such common understanding of what the final outcome will be for the living labs. So the ecosystem platform where the digital twins and the Serious Games are part of this is going to be presented to the end users as a set of number of functionalities and services that might be instantiated before to be deployed. Instantiation is a sort of negotiation between the technical partners and the living lab owners in order to say, okay, which are your main benefits, which expected benefits, which are your main needs. What do you want to negotiate? Which are the main limitation and constraints? Which kind of solution do you already have in place? Do you want to integrate? And which kind of solutions do you want to be part of the ecosystem platform? In that case, it is possible to have a sort of tailoring of the ecosystem platform in order to have a very fitting solution for each living lab that might be for sure different from one to another one. This phase is something that is for me is crucial for the final stage of the deployment. So it's something that probably is not a part of something that will be done in just one day, 1 week, or 1 month. It's a part of the project. So having such kind of interaction with the end users in order to better understanding which are their needs, what kind of solution they would like to have at the end of the project is to me is one of the main key points.
Yes, please.
Build on that. In an ideal world, you know, going beyond the project, several years beyond the project, how would you see the Precinct tools being delivered to end users? Is it a set of independent tools or consultancy services that individual organizations can deliver, or could it be fully integrated as a package? What are your thoughts on that?
Yeah, just very quickly, I think we've discussed this in the past, Mark. Certainly from our perspective, I think the answer is both, really. I mean, certainly we would definitely offer what, the resilience assessment framework that we're developing as a standalone offering that we can give to users as a consultancy service. But likewise, there's no reason why the integrated systems, they work much better together, that they couldn't be put together. But I'm sure the other panelists have thoughts on it.
Yeah, well, I suppose I'd agree with that. I think the most powerful and what we would all like to achieve is that it would be a precinct. So you have your precinct that does all the things that we're describing. That would be the most powerful thing. But the world isn't perfect, So.
There was another question in the other corner of the room.
Yes,
please.
Thank you very much. Yes, I'm Frederic Guillemard from EDF, and I'm also the project director for a Praetorian project in H 2020, such as PRECINCT. First, thank you for the quality of your answer. It's very rich, so not easy to select the smarter question I could have, but I've got 2 comments and 1 question. First, I think for the CIs, the objectives is, and we don't talk too much about that, it's business first. Then we have services with these critical infrastructures, and we need availability. Secondly, the second step, this is supported with safety. We don't talk too much about safety. I think in the industry, we need to talk a lot of that because it's always present. Us at EDF, the power plants, the first word is safety, 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 safety. It's like in the avionic world, it's the same thing. To do that, you talked about resilience. I think it's one pillar. We also have integrity. And again, the last step, because we are talking about cyber physical systems, we need and we develop tools, solution about cybersecurity. This is the last one. But now in our industry, we can't have all the steps before without cybersecurity. And my comment is only about the term of cyber physical systems. We have to take care when we speak about that. When we speak about cyber physical threats, we don't talk about digital. We don't talk about cyber security. And in the wording, I usually heard about that, but it's not directly cyber security. Cyber physical system, there is no cyber security. So we need to implement this and to develop the techniques for the risk analysis to be compliant with the resilience, the cyber security, not only cyber such as digital, and to combine this. And my question is how to combine this with dynamic mode, because I think it is what we need in our industries, in the factories, in all where there is critical infrastructures, to manage the risk being more dynamic. Sorry for the question.
Maybe I'll take a first step at that. I think it's a very valuable comment, because as you were saying, in the industry planning, the preemptive part that we are focusing on in PRECINCT is the one thing, but I also want to have resilience estimation, risk estimation on the fly, dynamically, as you said. And as I have experienced it, as maybe we have experienced it, it could be quite difficult to do all the modeling, the simulation in real time. And me personally, I'm not sure whether it is a computive power issue, so that if we get more, I don't know, more power, more calculation time in the cloud or whatever, then it's going to be faster, or whether it is an algorithm approach where we need to have more intelligent algorithms. It's from right now, from today, it's not clear whether it's the one or the other. But I think if we want to go into the real-time assessment, and I think this would also be one step after PRECINCT, after we finished, this would be also a main profit for the operators of the critical infrastructures.
Yeah, to follow on, we actually we had this discussion briefly, and then when we came back to it, if you think about a flood, like physical events are fine, you can model very highly accurately with different levels of flood. You can find out what the what the impact is on your infrastructure. On the cyber side of things, I'm no expert at all, but it doesn't seem to be as well defined for me. Physical events are very well defined. We've measured them, but for the cyber events, for me, looking on the outside, it seems like there's not as much data to be able to provide that information. But we did talk about this kind of live updating of the game. And we all came to the conclusion that maybe that's slightly beyond the PRECINCT project, if you know what I mean. But I think it would be a great future direction to go in, Yeah. I think he's just finishing up a commentation.
Sorry, yeah, just very, very quickly, just to basically just agree with Daniel. I think real-time resilience, absolutely. I think we all agree it's the future. It's where we want to go. Again, like Stefan, I can't be certain why what the exact barrier is, but certainly as well as computing power, it's data, getting the right data quickly enough. I think it is definitely a step in the future. It's still something that we can work on right now, but I would see it as being slightly outside of the scope of what we're trying to achieve in PRECINCT.
And as well, I suppose the main focus of PRECINCT is the interdependencies, so all these infrastructures have been, as people have mentioned before, have been, looked at separately, but a huge part about PRECINCT is the interdependencies, so maybe we've got over-focused on that, it's a very good point.
There was a definition of living labs given in Shirley. So if I understood dynamic mode correctly, isn't this one aspect of the living lab? I mean, the dynamicity is that you have the users, the infrastructure, and IT tools put in a real context in the living lab and observe what will happen. So how this can be taken into consideration? To have real users using the PRECINCT tools, the Serious Gate or the others, and observe in an airport what are unforeseen. Will the tools operate properly?
Yeah.
So is it what you think about dynamic mode, or?
There definitely will be that validation going on in the living lab. Sorry for jumping in, guys, when I'm not on the panel, but there definitely will be. That's the point of real scenarios from real users. But obviously, we're not planning to plant a bomb in the airport or, in fact, do any or flood Antwerp. So yes, we will be trying out various scenarios with real users and with real data as we can get it. But hopefully we won't have to do anything real time there.
It may be trying to address your question. I won't say I will answer your question, but address it. How I see living labs is that indeed lots of stuff is going on, and lots of changes with lots of stakeholders are taking place. I think what you need to build into this living lab is the difference between what they call the intelligence, which is there, but the wisdom. Wisdom is about learning, continuous learning. You need to be able to facilitate at the end that you have learned a lot. How we see that is that, for example, if we have been talking about that, if you could standardize to become technical scenario in some way, then and the digital assets that you used to run that scenario, then you could quickly or easily store the artifacts that were the result of a simulation, for example, where all the stakeholders were active. And next time you could redo it with other assets, and then you could compare. You could start compare actions that you did during the living lab, because it's a time span, and you could start relating that even afterwards what you did and there was changes. So you could learn from your Living Lab experience, but for that you need to store the artifacts. You need to be able to store the things that you used from Precinct in the actions that you did. I think that's an important element that could assist the learnings of a Living Lab, because in the end, a Living Lab is to learn about what you did and to experiment and to make sure that people get into the mood of using the technology to address their questions. So I think that's an important aspect of that, which needs to be thought about.
Oh, there's another question from the floor, please.
Thank you. So I was very interested in the concept of monetary cost for measuring stuff. I'm perfectly fine with this. So it's very common in the insurance and security industries. Now, I was wondering, there are some things that are very difficult to measure in that with that metric, obviously, like life loss or maybe productivity, stuff like that. So what happens in real examples is that the stakeholders are the ones that put the value to these things. So this will make a lot of changes in the games and how the solutions are found. And so my question goes into that sense. How stable are the solutions that we want to find with artificial intelligence? I'm sorry, with artificial intelligence or algorithms, and how are we working with the uncertainty of the solutions that come out of the Precinct?
So I mean, to come in quickly on the cost and the stability of that, it's absolutely a key issue here, is that there needs to be some objectivity to that, because we're dealing with different infrastructure owners. Obviously, the concept of valuing human life and valuing delay costs, things like that, it's not a new one. It's been studied for years, but you really need to have a consensus, which is why that discussion period where we quantify these things needs to be collaborative, involving not just the stakeholders of the individual infrastructure, but also the regional authority, how they value it as a whole, and probably some other objective means to make sure that it's all being quantified in a coordinated manner. As for the uncertainty, it's probably maybe a better question for the interdependency graphs, because we're dealing with the probabilities in that case. So I don't know if you, maybe Stefan, want to come in.
So you're of course very right when you say that with uncertainties, we never know how a specific incident will affect the entire network of critical infrastructures. So what you would have is, you would have maybe historic events. You would learn from other infrastructures, maybe in other cities, that were affected by a similar incident, and then could make an estimation. But to account for that, what we do is we have this, as you just said, this probabilistic approach in modeling the cascading effects. So we are not saying that it is a deterministic, predefined way how the Kennedy Tunnel, for example, will be affected by a flood, but it can be more or less affected. It could be having these or that effects based on a probability. So in that way, we could also have outliers in the simulation that would show you a worst case scenario or maybe a best case scenario. So in this way, we would account for these uncertainties, or try to integrate these uncertainties into the estimation of the cascading effects.
Thank you. My question was more into for the decision makers, what kind of outcomes are being presented to them in order to make them understand uncertainty and probabilities, because this is a somewhat difficult concept sometimes for people that are not experts in statistics, and they just go for the most likely outcome or something like that.
Yeah.
However, there are other more advanced ways of presenting the information, or making them stochastic optimization scenarios, stuff like that, that can help them make better decisions. I know it's on average, but it's yeah, that's the idea.
I just think that's a really good point, and it probably we hadn't got there yet. But I think in terms of the reporting from the serious game, I think that's something we could definitely work on, actually. And when we meet with the Living Lab partners, we're all talking about resilience, but as you said, there may be other metrics that they may want to include there. I mean, I'm not saying we changed resilience or anything, but you know, we'll find out from them when we meet with them in the next month or two. And it's a very good point, actually. We probably hadn't got there yet, but yeah, very good.
In our experience also, they change with the administration. So when there's elections or something, then they want to rebalance the, the value of things.
So let me cut in. We're running out of time now. What I'd like to just do is give each of the panelists basically a 30-second to 45-second opportunity to say what they believe the key message is for Precinct, of Precinct, for the future in relation to the technical aspects. And we'll go in reverse order. So we'll start with Gabriela. 30 seconds. Sorry, elevator pitch.
Okay, thank you, Mark. Since today we have talked about solutions and opportunity from coming from the technological and the methodological aspect, I would like to point out that the European Commission wants to have a solution from us and can help us providing such kind of European projects for policy initiative, where we have the chance to provide to the European Commission whatever we have carry out within the PRECINCT project to be made available for policymakers or for other external stakeholders.
Excellent. Thank you. Stefan Lefebvre.
Yeah, what I've learned today is that the Precinct installation requires integration of lots of cutting-edge systems, and that bringing these systems together is a value as such that is in Precinct, I think, very important. My dream for the future would be that we have lots of precincts everywhere and that you could create synthetic data, because we hope that disasters don't happen every day. Synthetic data that can be used that can be transferred from one place to another using transfer learning of AI or I don't know what, so that we then can use that to have more realistic presentations to the policy takers about that, and that we can calibrate it with data from real disasters.
Thank you. Daniel?
Yeah, I suppose from today that I've kind of looked and what I'd like to say at the end of the project is this: we're starting to move into the user-centric phase of the project. I think now we've talked a lot about how we're going to do things, but now I think we're moving into that phase. So I'm hopeful that at the end of the project we have a Precinct ecosystem that is user-centric and they get what they want from it. And then they see the future benefits of what it can do. We've discussed some of the potential future benefits in terms of the serious game and the digital twins. And to me, maybe there's 2 more funding projects. I don't know, anyone else?
And Stefan?
From my perspective, what I think city administration, what CI operators would need now and in the future is a comprehensive and holistic overview on the infrastructures that they are managing, that they have the hand on, that they need to protect. And I think that Precinct, with all the integrated parts that we have, with all the solutions, would be able to provide that view to them so that they can make better decisions in the end.
And finally, Dorkan, please.
So yeah, I guess we've probably all kind of touched on it already, but it's really just the matter of integrating these tools together, demonstrating it in the individual living labs. I think if we achieve that for multiple hazards, for multiple infrastructures, again, it's already quite a nice step beyond the state of the art. And finally, then I think in line with the business requirements that we saw earlier on, if we can commercialize this, if we can demonstrate this even, we'll have done a very good job.
Excellent. Thank you very much to all the panelists. Thank you to all the participants. I think you did an excellent job of covering all of the areas of the topic. And clearly, I would like to give you a round of applause for all the panelists. Thank you. Now we can move to the next session. Thank you.
Thank you all. Bye-bye.
Thank you, Mark. I echo your sentiments. It was a really great session, really enlightening, and thank you very much for moderating it for us. So we had a slight change round of the agenda. I don't know whether anybody noticed, but we're now going to be moving before our coffee break to our next speaker. So this is our guest from the EU Hibernate project, Päivi Mätelä. I hope I pronounced that correctly. I'm sure you will correct me if I'm wrong. She holds the position of Director of Security of the Research Programme at Laureate University of Applied Sciences in Finland, and she's responsible for quality and growth and strategic goals of Laureate Security research and development activities. Dr. Mätelä is the coordinator of the EU-funded EU Hibernate project, and she's a Doctor of Philosophy and previously has worked as the head of the project development unit at the Crisis Management Center Finland and from the Finnish Embassy in Tel Aviv. So welcome from on behalf of PRECINCT to you, and thank you for joining us. And we're looking forward to your presentation. Thank you.
Thank you a lot for the kind invitation to present EU Hibernate project in the PRECINCT event today. I have one question before I start: how to change the slides? This kind of technical problem. Okay, great, thank you. So it's really my pleasure to tell about the EU Hibernate project in the very beginning, so that you do know where I'm coming from and where the perspectives are coming from. And then, of course, there will be plenty of insights to the critical infrastructure protection. And I can say that I have been very inspired of following the discussion today and the presentations today, because I see that these two projects has plenty of in common and plenty to learn from each other, or at least I have learned a lot. So thank you a lot. Okay, so here you can see the agenda. First, the introduction to the EU Hibernate project and how we are linked to the critical infrastructure protection. Then I want to deliver for you the latest insights from the EU Hibernate project in the critical infrastructure protection domain. And then EU Hibernate's latest recommendations and findings on innovations to counter hybrid threats in the critical infrastructure protection domain. And then future aspects and conclusions. So first I want to start to tell about the EU Hibernate project, so what we are. The acronym is coming from Empowering a Pan-European Network to Counter Hybrid Threats. And we are dealing with the hybrid threats concept defined by the European Commission. And it has some own aspects that I will tell after this slide, but in this slide I want to tell what we do in the project. So we are to build European capabilities to counter hybrid threats, and how we do it, it's described in these 4 blue boxes in the middle. So what we do in the project, we start always to map the pan-European security practitioners and other relevant actors' gaps and needs, vulnerabilities to counter hybrid threats. And when I say the other relevant actors, I mean academia, industry, SMEs, and NGOs, because they are those who are also countering hybrid threats and delivering the solutions for pan-European security practitioners. So first, there's always this kind of event where we get together and analyze the present pan-European security practitioners' gaps and needs, vulnerabilities to hybrid threats. This is followed an analysis that will be done in 2 phases, a long list of gaps and needs, and then a short list of gaps and needs. And it will tell for us, for the project, what are the most critical gaps and needs and vulnerabilities to focus on. Then we start to map innovations, most promising tools and solutions that could be answers to these gaps and needs. And then there will be a more thorough analysis of the first mapping of the innovations that can be technological innovations or non-technological. And when I mention non-technological, it means, for example, training, standard operating procedures, etc. And when the promising innovations have been selected, then there will be a training and exercise event where those who participate to the Gaps and Needs event will also test the identified solutions. And this is the validation point, how we see the promising innovations, technological and non-technological innovations. And after this, there will be the analysis of these innovations. There will be the most promising selected for the innovation uptake recommendations and innovation standardization analysis. And this is, of course, to tell for the pan-European security practitioners and other stakeholders what are the future measures to take into account when we talk about countering hybrid threats. What are the actions to take? What are the tools? And of course, we also want to tell for the European Commission and funding institutes and instruments, what are the future solutions that we really should focus on, develop further, etc., in order to enhance the pan-European response to hybrid threats. And then we are not doing this alone in the consortium. We have the EU HypeNet network that is open for applications. So if you are representing industry, SMEs, academia, especially security practitioners, so welcome to join the network, and then you are part of this work. And yeah, let's go next further. And how we define the hybrid threats. It is based on the European Commission approach of hybrid threats. That's called the landscape of hybrid threats, the conceptual model. And it's delivered by European Commission Joint Research Center, JRC, and the European Center of Excellence for Countering Hybrid Threats, hybrid COE. And here you can see the document. This is the approach, how we define hybrid threats, how we do our analysis, how we do our research. And here's the link to the public version of the document. And on the left side of the picture, you can see the main approach in the conceptual model, how to define the hybrid threats. Here it is in a bigger format. So when we talk about hybrid threats, there's always an actor behind. It's a state actor or non-state actor, like a terrorist organization. And the activity targets to harm the member state, the city, the region. And the adversary is using different kind of tools. Here you can see a big list of different kind of tools that can be used. And the key is that they target certain domain. Infrastructure is one of the domains. And of course, when I next tell about our results, I will focus on this infrastructure protection aspects and domain. And the adversaries, when they plan the activities, they might target many different domains, either simultaneously or after a time lapse. But still, they plan the activities so that they can harm the domain and the activity that they really want. So there might happen something in a legal side and political side, and the target is infrastructure, actually to harm the operations in the critical infrastructure domain. Or the state or non-state actor might plan their activities so that they target intelligence, infrastructure domain, and target is once again to harm the infrastructure. So it's important to understand that when we talk about these domains and tools, there really are many activities taking place perhaps at the same time or in a 1 year, but they are all connected together. And then this, of course, is leading to the cascading effect as well in different domains. And the activity that is then targeted, it's interference of the activities, influence, operation or campaign, or the end result might be even in warfare and war. And the main goal is to harm the decision-making capability. And thank you for Stefan. Today you mentioned in the panel that the solution and the views you have in PRECINCT, so they are really online with this. And how we then use the conceptual model. So here you can see the approach once again. So on the left side, there are the 13 domains that the hybrid threat actors use and where the hybrid threat takes place. And we identify the pan-European security practitioners' gaps and needs, the most critical ones inside these domains and how the domains are interlinked. And we always deliver results out of these EU HyperNet 4 core themes. And here's a more precise picture. So you can always expect gaps and needs and then innovative solutions to counter these gaps and needs in the context of countering hybrid threats from future trends of hybrid threats topic and theme. Then also cyber and future technologies. What are the hybrid attacks and threats taking place there and what we should do in order to enhance the pan-European measures in this field. Then we have resilient civilians, local level and national administration, one topic. And last but not least is information and strategic communication when we talk about disinformation, information manipulation and interference. And as you can see from these topics, all goes well with the critical infrastructure protection as well. And here is a picture from PRECINCT project, how you see the cascading effects. And I have wanted to add this here because we are fully in line with this. And thank you for Stefan, Schauer, and Jenny and the consortium. You presented this in the EU HyperNet annual workshop in April of May. So it was a great presentation. And this really links us together, PRECINCT and EU HyperNet. Okay, let's see. Now I'm jam. Is the next? Uh-huh. Mm-hmm. No. Ah, okay. Well, thank you. Technology. Yeah, so this picture is to highlight how we also share the legislative background that is similar to us. So in the first column, you can see this critical entities resilience directive proposal that is now coming from the Commission. And of course, I think and I assume that PRECINCT will definitely contribute to the critical entities resilience directive implementation. And EU HyperNet is also sharing this goal, but from our perspective, because here you can see the conceptual model approach or the domains that are important for hybrid threats. So with the color coding, I underlined that, yeah, they are the same domains. And then if we go to the network infrastructure security, or what is this NIS directive proposal? So it also links these three all together. So we have the same background and same goal to deliver solutions to these political document implementations. And here are the results. When I mentioned that we analyze the gaps and needs to counter hybrid threats, these documents deliverables are consortium only, so I couldn't highlight the results properly. So I made it in a format of threats, not gaps and needs, but threats. And then we, of course, have proceeded in our analysis what is needed there. And here you can see the 4 core themes from the project and under which I have then put the main aspects. So if we start above of the PowerPoint, so there is the exploitation of critical infrastructure weaknesses and economic dependencies. So we see that in the hybrid threats landscape, this is in the key aspect when the adversaries try to harm European member states and activities in the critical infrastructure landscape. And what is then seen necessary to focus on is the foresight to reduce dependencies, strengthening cyber protection and defensive measures. And I see that in PRECINCT, your solution is much into this. And then, of course, it's a big interest of EU HypeNet to get into further cooperation with you. Then other critical threats that we see in the field of critical infrastructure is exploitation or investment in companies by foreign actors. So we are talking about foreign direct investments. And when we are talking about critical infrastructure operators, they are public and independent ones. So then once again, it's an issue that is good to keep in mind when we talk about critical infrastructure protection. So there's an additional element that can cause harm to critical infrastructure activities. Then in the field of cyber and future technologies, we have identified that space interference and counter space weapons are a threat, a big threat in the landscape of hybrid threats. And what is necessary then to focus on and improve our measures to solve these hybrid attacks and hybrid campaigns and threats is to improve strategic space capability and emergency preparedness. Also to find cybersecurity solutions in order to prevent harming the space activities. Then disruptive innovations, that is one threat that we have also identified. And when we talk about disruptive innovations, there might be a question how to use 5G, artificial intelligence. And necessity is to foresight for new future challenges. And as you do know, I have learned even more. So in PRECINCT, you have the foresight much in your focus. So once again, there is similar needs identified in our case. And then information and strategic communication. So foreign interference in key information institutions. So what is a necessity? Increasing awareness and countermeasures to interference. Today we had a good discussion in our lunch table that is information coming a new critical entity. How much can be harmed with the disinformation when there is an attack to critical infrastructure operator, and how to affect the citizens and how to escalate the situation even more. And then last but not least is the future trends of hybrid threats, so digital escalation and artificial intelligence-based exploitation. So what is needed there is seeing the joint procurement and dual use technologies. And here's one innovation that we have found as a promising, a suggested innovation to cover the gaps and needs from the first cycle of the EU HypeNet project. So the full cycle of gaps and needs and identifying promising solutions. So we are talking about common information sharing and analysis environment, CSI, to public-private information sharing networks, to developing collaborative investigations and collective activities and actions. And yeah, this is to develop critical infrastructure sector specific CSI and analysis tools. And once again, I noticed that we are very much in line with the PRECINCT activities, that the information must be shared not only in one domain, but across many domains. And last but not least, this is my final slide, some insights for the future. So what is under discussion at the moment? So if we go to these two directive proposals that are now coming out from the Commission, Critical Entities Resilience Proposal and NIS2 directive. So we noticed that these directives do not include reporting on weak signals that often indicate hybrid attack. So if we lack these noticing weak signals, we are not that well prepared for the cascading effects, because everything always starts from something, and before it's there really visible, it might be too late. So this kind of greetings for the Commission, and we have the future development of these two directives. And in the case of hybrid threats, we always talk about weak signals. Then public-private cooperation is needed to counter hybrid threats also in the critical infrastructure domain. So this is obvious from our side. And then there are some code words that we have noticed in the case of hybrid threats from the hybrid threats protection angle, what needs to be there. So holistic approach, that is a starting point. Then a hybrid attacks targeting space domain. It's now plenty under discussion, and we have noticed and discovered weaknesses there. Then foreign direct investment everywhere, especially in the critical infrastructure domain, is important. European self-sufficiency and strategic autonomy in a critical infrastructure domain, it's a key aspect also to pay attention and find solutions, strengthening this domino and cascading effects that you well have recognized and are working on. Then one element that we are dealing with at the moment is need to identify attacker's signature. Pan-European information sharing needed in many domains. And when we talk about this identifying attacker signatures, so if we can see that there are many similar attacks taking place, perhaps we can find the real attacker and really then go to the core of the problem and find a solution for that. And then insights. So as mentioned, we see the non-technological innovations as important as the technological ones in many cases to counter hybrid threats and also in the critical infrastructure domain. And here I can underline the importance of training and then of course serious gaming. So that's one. And that was all. I thank you.
Thank you. Thank you very much. Thank you very much to our guest speaker. So we're now going to go to a coffee break. So we'll stick to the time schedule if that's okay. So we've got a slightly longer coffee break, an extra 5 minutes. So thank you all. If you can stay online with us, we'll be back with you shortly with our concluding session. Thank you so much.
We're just trying to get two online and to our panel. That's Vito and Dennis. So yeah, this is the final slot of today, graveyard slot, whatever you want to call it, standing between people and their flights, trains, perhaps the bar. So we'll try and crack on and make this a little bit interesting. Okay, great. We've got Vito there from engineering, Dennis from ICS. That's great. So we'll kick off. This final roundtable is around, okay, outside this consortium, outside this project, how are we going to make this real? And what are the possibilities? What are the drivers and barriers for implementation of new CIP solutions? We're going to talk, hopefully in a roundtable format, explore needs and drivers, perhaps building a little bit on that discussion this morning of the user community for, around combined cyber-physical threats and cascading effects. The barriers that might hold back implementation of those solutions and potentially
solutions enablers to overcome those barriers. So what we're going to be doing is we're going to have our five panelists here are going to each introduce themselves briefly, very briefly. Some of them have been introduced already. And then I'm going to start the ball rolling with a few questions to the panel. As and when that dries up, or maybe doesn't dry up, I'll open the floor to other questions. So if I can ask the panelists just to give yourselves very quick introduction, and if possible, give me us all an idea of your perspective on CIP. For instance, where do you see yourselves in the supply chain? Sorry, not the supply chain, the value chain for CIP. From what angle are you coming on this? So Päivi, can I go with you first?
Does this work? No? Does it? Yep. Okay, now it works. So hello, everyone. Once again, Päivi Mattila from Laurea University of Applied Sciences, Finland, Director of Security Research Program there and EU HyperNet Coordinator. So I am representing academia, but as I mentioned in the morning, so before I came to Laurea, I was working head of research and Project and Development Unit at Crisis Management Center, CMC Finland. And it is about crisis management missions in the scope of EU and also civil protection measures and missions. So then I had the hat of practitioner, so to say, coming from the first responders and crisis management side. Yeah, so my comments will come from these perspectives today. Thanks.
That's great. And I think given what you said about EU HypeNet, also perhaps a little bit of an expert on the policy side of things.
Yeah, and hybrid threats. So
Yeah.
commission policies, etc. Thanks.
Thank you. Misa.
Hello, good afternoon. I'm Marisa. I work in Tecnalia, that is a research center based in the north of Spain, in Bilbao. I'm working in the unit area and all in the digital unit. I'm more focused on cybersecurity aspects. Our main role of Tecnalia role in this project in PRECINCT is based mainly in three main pillars. The first one is the monitoring, a monitoring tool for detecting cyber attacks in the critical infrastructure. The other pillar is the cyber range and the cyber exercise. The cyber range are a platform to simulate operational environment to train people to react to potential cyber attacks. And the last pillar is we are leading the capacity building for stakeholders, so the training part of the project.
Okay, good afternoon, everyone. I'm Benoît Borins from AK Technologies. AK is a consulting and engineering company, soon to be merged with Modis Group. So we are becoming a very big actor with a worldwide footprint in consultancy and engineering services. So my background is from the IT side. I've worked as a computer scientist for several years, especially in the telecom sector, dealing with telecom operators problematics for ensuring reliability and a good service level of telecommunications infrastructures. For AK, of course, our business, our job is to help our customers to deal and to solve problems, let's say, and of course, cybersecurity and protection of critical infrastructures are one problems very pregnant in today's world. We have a kind of innovation department where we try together with our customers and in the frame of European programs as well as we try to address ahead these problems and how technologies could try and propose solutions for addressing these problems. Okay, so I will also act in this discussion from this technology supply perspective.
Thank you. Go to Dennis online.
Yes, I hope that you hear me.
Yes, we can. Thank you.
First of all, I should apologize. My office is nearby the student campus and here is the concert right now. So I hope that this not interfere so much. About my perspective, I will discuss today as critical infrastructure protection domain expert. I have privilege in my long career to be in a different side. So I have pretty much good knowledge after 30 years of service in different national security authorities. The second part of my story is related to the Slovenian Corporate Security Association, where I am the president, and in this association, almost all Slovenian critical infrastructure organizations are in place. So I have pretty much good insight what is the main problems in this respect. And also I have good knowledge also regarding the NATO and the EU environment regarding the critical infrastructure protection. So my discussion will go through all this spectrum related to the problems which we are facing related to the critical infrastructure protection area.
Thank you, Dennis. And last but not least, Peter.
Yeah, good afternoon. First of all, thanks for inviting me for attending this panel. I'm the director of one of the research and development labs in engineering. Engineering is an Italian system integrator. Actually, we have also business outside Italy, but 80% of the business is in Italy. My lab is about industry and security, including defense, and on the industry part also the agri-food. We have in the lab there are almost 100 researchers, and we have something like 50 running projects, research projects. So these people only work on research. Of course, I'm representing the industry in terms of we are a solution provider. I think it's important to say that we are not a product development company. So we provide the specific and dedicated solution to our customers. So I think this is important because normally this is not adapting a product to a specific problem, but to develop and deliver a specific solution for a specific problem, for a specific context. So in this panel, of course, as you know, we are really active in the research part, in the security research part. We have more than 20 projects running on security, not only on critical infrastructure protection, but also on the other areas of security. So as I was saying, I can bring here the perspective of the industry, the solution provider, but also the perspective of the applied research. Which is aimed exactly to develop specific solutions for so security solution in this case for the operators in the specific context.
Okay, thank you very much, Rita, and thanks to all the panelists for agreeing to contribute to this. As you can hopefully see, a range of perspectives from the supplier side to the practitioner side, the policy side, training side. Domain experts and national and international knowledge of CIP implementation. So I'm going to kick off with hopefully a very short question, and it kind of relates to what we were talking about this morning. Can you pick out for me what you see as the key problem rising from the combined cyber-physical threats and/or cascading effects? There are many, there are various, but just maybe pick out one or perhaps two. So I go with Päivi first.
Okay, yeah, thank you. So if we are talking about the cascading effects and cyber-physical threats and attacks and so on, they might start from an activity and then really escalate and have the cascading effect. And then it means that many different operators are infected. So you really need to be well prepared in order to prevent the damage to go even larger. So then we really need to have the system that supports information sharing, joint reactions, coordinated actions. And of course, the training, as we have noticed and learned, is important for this. So it's the best way to prepare yourself and the other who's are needed in the coordinated response. So yes, I think the challenge still is the information sharing, interoperability and cooperation on a time when it's needed.
Marisa?
Yes, I think that one key problem in this aspect is the complexity of the system, because if you have just one critical infrastructure, the complexity is big. If you have a cascading effect, the complexity is huge. So it's multiply a lot. So as Päivi mentioned, I think that the communication is the basic, the sharing knowledge, because probably each operator of its critical infrastructure knows their own problems, their own vulnerabilities, but not the other critical infrastructure. So to sharing this knowledge is basic. For that, I think it's important as to be ready to react as soon as possible. For this, I think that the simulation, the training, and of course the communication are essential points to be deal with.
Thank you. Benoit?
Yes, I think we know that operators they are looking at their own business first. Of course, they are busy with their own business. So as you said, they are knowing very well their own infrastructures and how to protect them or how to react, but they are less aware about the consequences that might cascade again. So I think awareness about that, knowledge about that, and preparation are key elements. And I think that PRECINCT solutions will help in raising this awareness for the different operators, because they will see that, okay, we provide tools like knowledge graphs that illustrate what can be the cascading effects on some critical infrastructures in some regions. So it will formalize very concretely what can happen and where the actions are needed and the preparation are needed. So again, the preparation and the training are important, but it's perhaps not the core business or the priority in general. So I think the benefits of a project like PRECINCT with the Living Labs demonstrations and validations will be to raise awareness about this complexity, and that they are part of a global ecosystem in a region or in the city.
A common theme of communication, awareness, training already arising here, given the complexities. Dennis, can I go to you next?
Yes, Mark, of course. You opened the Pandora box with these questions. I will look maybe in a little different perspective to the challenges regarding the cascading effects and interdependencies between critical infrastructure protection. So the main problem regarding the operational environment is that we're still working in silos. So we are still in a security silos. This security silos is divided in the physical cyber world, and this morning we heard that we have beside the security silos also the safety silos, and this understanding of the nature of the problem is different regarding the people from these silos. So the first and the most important thing from my perspective is common understanding, that we understand what is the threat, and if we say cyber attack, we all understand what is the cyber attack and what is the consequences and what are the operational procedure to provide this. And for this reason, terminology is the first step, and of course understanding and awareness and all these common activities further on. The second point I would like to raise is the complexity of technology. So it is really difficult to find inside the critical infrastructure experts who really understand the whole systems inside this complexity organization. If we are talking about the multi-organizational environment where we have different critical infrastructure sectors, where the specifics are different, then we are really in trouble. To have this really good operational or tactical or technology picture, because when we are talking about the cascading effects, we are talking about the small things which make big problems. The next thing which is important is awareness among the strategic management. So it is not so much problem awareness about among the operational level or in expert level. The problem is understanding the criticality of this procedure in a top management, because you know the top management are mainly focusing financial and operational threats or risks. And this security risk is in maybe second role for them. So when we are discussing about the critical infrastructure organization, so this is the must that the strategic management should understand that, of course, the business procedure is the first, but if the security and safety conditions are not here, also the business continuity of the process will be in problem. And for my last indication or indicator, I would like to stress that especially in the field of critical infrastructure, we have really very strong involvement of private sector. So we should really work on the private-public partnership, because I go to the beginning. We have the different understanding from the private perspective and from the state perspective, what is the critical infrastructure and what should be done. And from this reason, this partnership should be one of the key priorities for discussion in every level, strategic, operational, or tactical.
Thank you, Dennis. I'm glad you ended on a positive note. It's beginning to sound like a lot of doom there, but there's some positivities there as well. Finally, Vito.
Yes, actually in the question there are the two main dimensions, which are orthogonal dimensions of the problem, I would say. One is the cyber and physical, so the integration about the cyber and physical, and the other one, of course, is the interdependencies. Regarding the cyber and physical, even inside the same organization, as Dennis was saying, there is the problem of integration between these two worlds, because normally you have even inside not only inside the critical infrastructure operator, but in general in the organization, you have two different management of the two different kind of security. So let's say breaking this barrier or overcoming this problem is already a challenge. So it is not only a matter of technology, it's a matter of processes, it's a matter of responsibilities. So there are two different chief of security, chief of cybersecurity, chief of physical security. So this is the first point. Of course, if you, let's say, escalate these, consider the interdependency domain, the interdependency dimension, of course, you multiply the problem. The second part is, of course, you have different organization, different processes. So this is actually the problem. So what, and the people working with us know that we are working strongly on this, is to stress the concept of situational awareness. So what we believe is that there is a very lack of the achievement, the pursuing of these concepts. Situational awareness is not monitoring, so it's not detecting a problem. Situational awareness is a bigger problem. So what is really missing is to work on these and considering that you have to assess and evaluate the risk before the event happens, something that you can monitor. There is a problem related that the complexity that was already mentioned, that in some cases, threat or even attack scenarios are multi-threat, multi-attack, multi-actions scenarios. So connecting the dots is one of the problems, especially when some of these dots are really weak signals. So you can understand or you don't understand that the problem is coming. So what you are perceiving is just the initial of the problem. Another point is, which is related to the the complexity is related to the preparation. So there is a very, very small focus on the preparation. Preparation is not just vulnerability assessment. So it's prepare the response, it's prepare the mitigation. And when you add the interdependency dimension, this means a joint preparation and joint response planning or joint mitigation planning. Last point, very, very last point, people. People are part of the problem because they introduce threats, because they are source, in some cases, source or unaware source of attacks. If you think like just social engineering is an example of this. They are part of the context. So when you deploy or design and deploy solution, you have to consider people, their mindset, their education, their training, their knowledge, and they are, of course, part of the solution. So I think this last but not least point, I think, is one of the most critical parts, because normally critical infrastructure are not IT companies, but even in an IT company, you have a lot of people that are part of the problem, but they are not fully aware about that.
Thank you, Vito. So to add to that, kind of, oh, sorry, do you want to come back, Payne?
Yeah, may I? Does this work? Yeah,
Yes.
may I add something? Yeah. So I was listening the answers for everyone, and a very valid point, and it led me to think a little bit further. So when we are talking about cascading effects, so of course the cooperation and information sharing is needed then, but it leads then what I can tell from my response planning and joint response planning, what capabilities do I have? So it might lead to the situation that you need to reveal your vulnerabilities, and that might be an hindrance that you are not telling everything, and then it might affect that the joint response is then not that accurate.
Yeah, no, absolutely. I was just going to say, in terms of the complexity, there's also, people are bringing up the organizational complexity and the complexity of dealing with humans. So it's a key aspect. So I'm going to move on now. I'm conscious, by the way, that Päivi has to leave quite soon. Yeah, very soon. A few minutes. So that's why I'm going to Päivi first every time. Moving on to, you've talked about problems, but what are the drivers out there, and perhaps the externalities, which are forcing critical infrastructure operators, coordinators, etc., to adopt new CIP solutions, given the kind of problems we talked about? Are other drivers? I mean, as I think Dennis was saying, does senior management not actually see there are any drivers? So that's a problem in itself.
Yeah. Yeah, thank you. Actually, I was waiting this question. So I want to touch 1 second this Critical Entities Resilience Directive proposal. So I think many of us are very familiar with it, but it really puts a pressure to member state critical infrastructure operators to start mapping their vulnerabilities, and when they are attacked and this will cause harm to other critical infrastructure operator in their own member state or outside the border, they need to announce it. So now when it's in the legislation that you really need to announce, you need to be prepared to connect with the other critical infrastructure operators. So it really asks new type of planning, new type of preparations. So I see that legislation and this kind of directives, they are also a good thing, because they are then really enhancing the critical infrastructure protection and future cooperation as well. Well, there's still the challenge how to tell own vulnerabilities, but still this is one step to the right direction, if you ask from me.
So given you have to leave in a minute, I'm going to ask you a couple more questions and I'll come back to the others on the other thing. So, looking on the positive side, maybe this relates to the regulation, what could be enablers to help us overcome barriers and get these kind of solutions on the market? And lastly, given what you've seen today and heard before, what one thing would you want Precinct to focus on going forward?
Yeah, thank you. So short answers to big questions. So it has been wonderful to see how these living labs work together. They are many different actors representing different fields. So telecommunication operators, cities, different kind of transport actors, so train operators, airports. So actually this is the right way to proceed, that when all these operators that are needed to talk together how to proceed in a case of large-scale disruption and how to protect the joint activities in the critical infrastructure side. They are interconnected. So this is way forward, really get the actors to the same table and join together the future measures. And when they are having this discussion together, they also start to trust each other. And then the sharing the vulnerabilities and sharing the need to have a certain type of tool that will improve and enhance the future cooperation and measures, it takes the needed steps further.
Is that also what you think Precinct should focus on?
Yeah, and I think you're doing it already, but yeah, looking forward, the PRECINCT the two
Good.
as well.
Thank you, Päivi. So I'll go back to the drivers at Marisa. Again, thinking about those problems and needs. Thank you, Päivi. Thanks for joining us, and thanks for your contribution today. Appreciate it.
My pleasure.
Thank you.
And see you all.
Thank you. Thanks. Sorry, Marisa. You were thinking about all these problems, these barriers, perhaps. So what are the external drivers which are, driving adopters, users to take on CIP solutions? Or as I said before, are there drivers? Do we need to develop drivers?
I think that an important driver could be just to know that to detect a problem as soon as possible. This means that the consequence will be less.
Yeah.
So I think that this is a driver to be aware, to share the information, to take into account potential potential vulnerability from other systems related with other critical infrastructure related with yours. So to react as soon as possible, facilitate that the consequences are less.
Yeah.
Usually it should be less that if you wait till the problem was bigger.
Okay.
I think we said it that directives and political decisions could be, I think, very positive in imposing to the different stakeholders and actors, whether they are public or private, to impose some rules for being well prepared, well trained. I think this is very important from a technical side. Maybe and this is what we are tackling in the project as well. I think that standardization is an important point. We have been speaking about common information models. So speaking the same language, having some kind of agreement and standardization of the ontologies of these information definition is, I think, something that has in the future a strong impact in facilitating the exchanges between the different operators and ensuring a collaborative response to attacks. And the training as well, when we are trying to say that we integrate digital twins into serious games, and we analyze the behavior of people in front of different situations. I think this is very innovative, and the scenarios we want to implement in the project are really showing again how the collaboration and the common understanding, as you said, are important in the future. So this common understanding is, of course, having people work together in these training sessions and using these these tools, but also perhaps on the legal aspects in terms of directives, regulations, and again, common information models, development of ontologies and common vocabulary for everyone.
Yeah, thank you. I'll go to Vito this time just to mix things up a little bit.
Yeah, I think one key driver for if you look at the problem from the perspective of the operators, something that they want to keep is the integration with the existing solutions. So it's what they already have. So this is a strong requirement, something that we as providers must fulfill for sure. So this is important. If you look at the existing solutions, I would say that normally the monitoring or the detection part is almost okay, because they already have cyber detection tools or maybe leveraging on some products, cybersecurity product. The same could be for the physical security, especially when you have a specific critical installation, so maybe you have video surveillance, this kind of monitoring solutions. So I think at this level they are more or less okay, and this is actually something that, by the way, can be solved with existing solution. If we look at the problem from the perspective of a research project like PRECINCT or like the other project, we need to add something more. I think something that we need to provide and is also a need for them is awareness. So they are not fully aware about what is really, or what is the full risk. So this awareness can be provided, of course, with knowledge, but of course this awareness can be continuously updated with tools. So tools for risk awareness can be one of the requests they can have. The other point is actually inside your first question. So one is the integration. So something that can put together integration of the physical and the cyber world. The second one is, of course, the information sharing. And according to what our colleague said before, there is a need of shared, common, I don't know, maybe standardized information models, because otherwise there is a misunderstanding between the information exchange. So I think this is a point. One more point is probably there is less need. If you look at the critical infrastructure protection life cycle, perhaps the detection and the monitoring part, so during the event or when the event happens, is the most covered at the moment. So I think there should be some additional contribution and focus on the before. So as I said, preparation, risk assessment, threat intelligence, and after, because also the post-event analysis is important, because when something happens, and normally this is not just an event, this is a sequence, this is a set of correlated events, you can learn a lot in order to improve your protection, your performance, your security for the future. So I think also the post-event analysis is really important, and they are normally, this is not really covered in the current situation. So if we want to identify what can be the key drivers or needs, look, depending on the perspective, I would like to say this one.
Okay, thank you. And finally to Dennis.
Yeah, I fully agree with Vito. Maybe I would like just to add from this strategic perspective, what is the main push factor for this? This is demanding security environment. So we are constantly in some kind of crisis. The latest crisis situation in Ukraine showed us that a lot of cyber attacks was launched to the critical infrastructures. And this is the push factor for the critical infrastructure providers to understand and to aware that they should be better prepared with better technology and so on. The second thing I would like to raise is connected with Vito point of view. This is modularity. It is important because nobody will have enough funds to arrange everything in the procedural and technical part of the system. But this system should be open in a modularity way of view that could be then built with another systems, and this system could be connected between each other. The problem of vendors is that they sell products that this is the only products and they cannot be, you know, connected with some other vendor solution. And this is quite a big problem in the real time environment. Of course, I also agree that this solution should address the different challenges and, of course, the level of managing the threats in these different steps of the process. Probably the solution should be robust because we are talking about the critical infrastructure, protection environment, and some sophisticated technology solution are not robust enough to be, you know, good in every environment, especially those where critical infrastructure protection procedure and of course technology is operating. And maybe the last thing is, of course, that this technology should be not so complex, so easy to handle, because of course we could provide a complex technology, but as Vito mentioned in the first question, the human factor is problematic. Do we have enough trained personnel to handle this complex technology? So the technology should be easy to operate.
And maybe to reflect to what you're saying, Denise, is the technology must be simple and quite versatile, because things are changing every day. So we have to really consider the life cycle of the technology solutions we are providing, and making them sufficiently flexible to evolve in the time and to be maintained every day, I would say. So this is really important. And to come back to the point about standardization, it helps. And I think in PRECINCT, we are also trying to tackle that in terms of for addressing, for example, the deployment of services and software in the different configuration and settings. So this is important to be reactive in terms of technologies evolution.
I think I like how you guys are all being very positive and moving direct to enablers and solutions, you know, rather than thinking about just about the externalities. Just to go back to one point that Dennis mentioned earlier about the senior managers not necessarily having the awareness of what is required, what the complexity, what will they need to be prepared for. Does anyone have any perspectives on whether the market is ready for what we are developing? You know, is there enough awareness out there with the people who make buying decisions or you know, influence what is required in the future? Does anyone want to comment on that?
I'm not a specialist of the market, but maybe one question could be also whether the public and the private sectors are ready to collaborate and to cooperate tightly, more tightly than what they're doing at the moment, maybe. So these public-private initiatives are very important. So I don't know whether it's mature, whether depending on the different countries or regions, this cooperation mature, but this is perhaps an open question.
Yeah, questions still to be answered. Marisa?
Just for my point of view, that is more technology. If the things now go quickly, so if we want to have a very mature technology, probably it's not valid when when it's mature, because the attacks, the technology is very quickly. So if you want to have a solution very mature, that I understand in some cases is necessary, but if you wait to have this, probably it's not valid because you have other problems. So
yeah, gotta move fast. Yeah. Anyone else? Vito or Dennis want to comment on that?
Yeah, maybe Mark, I would just add to this that I always tell my colleagues inside the Slovenian Corporate Security Association that the experts in the field of corporate security, which includes the cyber security, the physical security, should be also not just an expert, but also a good sellers, so that they could, you know, provide quality understanding for the top management, how this new technology could help the organization to be better resilient, and of course to be better prepared for all these demanding situations which are focused all the time in the globe. So it's not enough that we are just an expert or good development of the technology, but we should have enough knowledge also that pursuit, and of course to prepare our customers to understand what we offer regarding the procedural and the technological point of view.
Absolutely. Any other comments on that?
No, just a few words to add, because it is so what should be clear is that there is not a specific product that can solve the problem. Okay, so the problem is as we discussed already, is a complex problem, and is a specific problem for each organization. So if you look only at the specific organization, so it is important to pass the message that there is not solution X solving, or the product X solving the problem. So we have to, when you design before delivering a specific solution that must address different levels of complexity, including again the existing solutions that you normally have. And normally when you have solutions in an organization, you already have non-integrated solution, because there are different IT managers over the years. So they buy solution 1 from provider X, solution 2 from provider Y. And normally they have to address the fact that these solutions do not talk to each other already. So the environment that we as a solution provider has to address is exactly this one. So there is already a problem inside the company in terms of solution. So we cannot go for a product or an integrated solution that aims at solving all the problems.
Yeah, absolutely makes sense. Just moving on in terms of questions. Oh, sorry, Stefan, you've got a question there.
Yeah, thank you, Mark. I wanted to maybe go back to the topic before about the drivers. And I wanted to ask the panelists, so at some point, what I took away from the conversation is at some point, the critical infrastructures would need to share some amount of data, some amount of information about their systems, about their vulnerabilities, having like a shared information, shared database about what kind of threats are out there. And I know that this is one of the particular problems, because critical infrastructures, they don't want to give out that information quite likely. And in that context, I wanted to ask whether, let's say, a trusted third party would be an enabler or a facilitator for something like the PRECINCT system. So in the end, the question is, who is running the precinct system? Who is having this overview on the city's infrastructures? Is it a city administration? Is it some other party? And the question would be whether critical infrastructure operators would be willing to trust some party, either governmental or something like this, to build something like we are suggesting in Precinct.
Anyone want to take that one?
I can say something. First of all, I don't think that there will be a Precinct system. I mean, an integrated system, an integrated platform. So at least my idea of the results is the idea of more of a framework, or even a toolbox. So something that can be of course, case by case used. Maybe not all the tools, not all the solutions can be used in a specific situation. So this is the first point. So in this sense, of course, you have a set of tools that in principle should be able to work together, because this is one of the purposes of the project, but they are supposed also to work with other pieces, other systems. Second, are the critical infrastructure operator available to, let's say, trust on a third party for managing part of their processes or their security processes? I would say they already do, because when they use some solutions on cloud, they are already doing that. And even if they are using Office over cloud, they are putting that system, they have to consider the risk associated to the Office, which is not a security solution, or maybe it is. So in principle, they are already doing this, but when you address the problem of where to deploy a security solution, this of course creates some concern in some cases. So the problem of the trust is of course there. So if you pose the problem and you pose the question of where to install the Precinct whatever toolbox, framework, solutions, whatever, maybe the answer is okay, on our premises. So it is a barrier, I think, when you talk about security solution that should be overcome. That's my feeling.
So you're saying, Vito, you make it simple enough that they install it in-house and they don't need to share the information?
No, they have, of course, to share information, and I would say that the sharing of information, I think there are two levels. One level is the sharing, the possible or the potential sharing of, let me call them raw data, okay, or lower level data. And I think in this case, they already do that, because they have trusted suppliers and they already share this data with trusted suppliers. The point is that solutions like Precinct or similar solution are supposed to share a higher level of data, which is actually information intelligence. I think this is something that they are more prepared to do, because it's not the raw data that someone else can analyze. It is the results of some analysis, and they can filter what can be shared. Of course, we come back to the problem of common data models, what can be shared in order to have a common understanding of the data shared. But this data shared should be for the purposes of an integrated security among interdependent critical infrastructure operator. One more point, Mark. When we talk about interdependencies, it's not only about between critical infrastructure A and critical infrastructure B, but also the providers of those critical infrastructure are part of the big graph of interdependencies. So if, as a provider, if I receive an attack, a ransomware attack, and they stole the password of your critical infrastructure, you have the problem. I have the problem. And this is related to these interdependencies, not between A and B.
Yeah. Okay, some good points there. Before I go back, I'm going to open up to the audience a little, see if your hands go up. Gabriela first.
Yes, so there was I have a related question regarding the sharing of information. So regarding the protection of critical infrastructure, is competition against protection of critical infrastructure? So more specifically, when you have two critical infrastructure operators, which are also competitors. So how this is managed? Will the one observe the other die and take the place, or is it? I mean, in this sense, can I accept that my competitor die and then
You were supposed to ask simple questions.
No, I'm trying to elaborate more on the orientation of my
It's
question.
a very complex issue of security. It's not just pure security; it's competitive security as well. Benoit, answer your colleague.
I think some answers are in your question, Gabriela, and also in the question of Stefan. I think I would say it depends on the. I would imagine it depends on the locations, and in some regions, in some cities, it can be obvious to decide who is ruling and operating some of the precinct tools. In some other regions or with some other operators, it might be a bit more complicated, and but we have to be open to all situations, all scenarios. We cannot say, okay, it must go through a trusted operator. We have to discuss and negotiate, and what are the consequences of decisions, and what kind of strategy can be applied locally. I think depending on the, I don't know, the expertise, maturity level and technical expertise of some operators, political issues. I don't know. So I think it depends. I would imagine.
Great. I thought it was a related question. I'll go to Porrick next.
Yeah, thanks, Mark. Just this session has been talking a lot about awareness, and I suppose as a comment on the question really is, is it awareness about the concepts that we're working with resilience and cascading effects, or is it awareness about, the lack of funding in this area, maybe to fund such initiatives from local government or from central government and larger agencies on a European level? Because there's no doubt that these types of threats are becoming more common and will become more common going forward, both cyber and physical, due to climate change and also due to more things going online and the use of data. So, the question I have really is, how much is public funding from central governments a barrier to this type of innovation, or is it about convincing private investors to help develop such industry tech like this that will then be sold or bought by local governments? So I mean, ultimately we're trying to provide solutions and innovation that will be used by critical infrastructure operators, right? And a lot of those are publicly funded or operated. So I mean, how much is funding for research and innovation a barrier to forwarding or to advancing the state of the art in this area is the question I have.
Good question. From my perspective, obviously, I'll say the private sector has a part to play, but open up to the panelists. Any comments on funding as a barrier or maybe an enabler? Where does it come from?
If I may, I think for some reason is not a barrier. I think because I'm just thinking of one topic that we already discussed, which is the information sharing. Actually, it's very difficult to think, okay, there are cases, for instance, in the telecommunication sector, but just a few cases in which the private sector, or I consider also that most of the critical infrastructure are national critical infrastructure. I mean, the very critical are national critical infrastructure. But it's very difficult that clusters of these critical infrastructure put money, for instance, to create standardized information models or something that they can share. So I think in this case, the public money could be a booster or a trigger and a booster at the same time to activate this kind of activities. Of course, when you go and you move to the field of security solutions, I mean protection solutions, you are in the middle between the public and the private sector. So in that case, could also be a barrier. I think the analysis could be a bit deeper, but could be, let's put it in this way, could be a barrier. But again, one possible booster coming from the public money could be in looking at the more complex scenarios. So maybe if you as a critical private, let's say, infrastructure have to invest in a solution or in solving a problem, you look at the closest problems. So you look at something that you have not solved already. So with the public money, you can also look at the more complex scenarios that are, let's say, closer to a defense or an hybrid threat scenario. Okay, so but we are understanding that these hybrid threat scenarios are not so far from us. Okay, so
perhaps the public sector has a role to play in terms of getting everyone onto that common playing field, same language, standardization, etc. But then increasingly the private sector can take over in terms of providing solutions.
Yeah.
Yeah. Okay. Anyone else want to comment on that one, on the funding aspects? Jenny.
Yeah, it's hi. Yeah, it's just a sort of generalized comment, but throughout my career, it's mostly been in maritime security, but it always, and some others in working for security in the police, but it always seems to be that funding usually follows some incident or some disaster or some, for example, ferry crash or whatever, and then funding appears to deal with that problem that is in very much the public thoughts and minds, and so the funding kind of usually follows that. And I don't know whether in critical infrastructure we always see those things as we do in some other sort of disasters, attacks or earthquakes, etc., because we don't always see the cyber attacks, we don't always see necessarily, unless we all have a blackout or something. So it's a really interesting topic about public funding and how that is calculated and how that can be a driver when usually it's the investment follows a specific event. Yeah. Thanks.
Thank you, Jenny. Are there any more comments or questions from the floor or from Zoom? Anyone on Zoom got any comments? No. Okay. I'm going to go back to the panelists. We've been mixing up in terms of answers and questions a little bit. You talked a little bit about some enablers already, some barriers. Apart from the things we've talked about already, like regulation, common language, standardization, funding, are there any other either enablers or to getting CIP solutions widely adopted or barriers to that we haven't mentioned so far? Risa, do you want to go first?
Okay, I think that we mentioned a lot of, of enablers and of barriers. I think that training it's a very important enabler to be ready. Common language. So I think that we mentioned the most of them. At this moment, I don't have any other in mind.
Yeah. Okay. Dennis, maybe should go to you.
Yes, I think, Mark, that Jenny raised the main problem which we are all facing, probably not just in the national environments, but also regarding the EU funds, so that some crisis should occur, and after that, we found the idea and the foundings and the project to the some specific things. We will not look into this direction, that we proceed in a way that we analyze what could happen, and that we try to evaluate this through the different projects. And maybe this is the main problem regarding how do we provide the adequate solutions which will be useful right now to protect us before some crisis situation. But I also agree with Vito. We should always look case by case, and we cannot find a solution to cover all problems and challenges. So, but regarding my point of view, the main challenging is how to proceed the top management to understand and to support all good initiatives, of course, which are costly and should be support with some financial parts, but this is important that we enable and speeding involvement, good technology solutions in the operational environment, which will help us to be better prepared and stronger resilience to the future crisis.
Thank you. Vito, perhaps you next.
Yes, I would like to stress two more points. One was already mentioned, which is the awareness. I mean, this is one of the most also to link to the previous question, because actually the awareness is at different several levels. So there is a very basic level which is related to the operators, but not only the operators and the people working within the critical infrastructure. They have not they are not fully aware about what can be the risk. So they are unaware about let me say normal risk, not something that could be related to a war or something serious. But so because in some cases when you buy a solution from a provider, okay, you are buying a complex solution. I'm not saying a security solution, in general, a solution to support the operations, whatever. You are buying a complex system. This system relies on a lot of other systems that can have cyber, but also other kind of vulnerabilities. So this complexity normally generate something which is actually unawareness. I don't know if the term is correct, but this is, you don't know, you are completely blind of what can be the risk. Okay, so there is, just to make an very simple example. So you can have in your system somewhere a solution, a software, whatever it is, that has a set of bugs. You don't patch these because you are not considering that there are these vulnerabilities. So I'm just making an IT example, but you can replicate these all over across the whole infrastructure. So this is the first level. The second level is the awareness related to what can be the problem which is not generated internally to your organization. Of course, this is related to the interdependence and what we already discussed, but this is nowadays, this is really actually a problem, okay? And it is important that this, so I think, and the third point is the awareness inside the critical infrastructure protection process. So when you are in a specific phase, which can be, let's say, even the detection, which is almost the most, I would say, the most covered phase at the moment. So normally the level of awareness is not really complete. So this is actually the awareness, I think, is something that is really important. The second point is just as a slogan. At the moment, the approach is really reactive. Yeah. So something happens, you react. So yeah. Of course, we can say again with the slogan that you should move to a more goal-oriented approach. Okay, what does it mean? This means that you should have KPI indicators, resilience indicator, whatever you want indicator, and this indicator should be pursued. So the protection should be not reactive, but based on achieving certain level of performance, security performance, critical infrastructure protection performance, or resilience performance.
Yeah. So really looking at a long-term perspective on CAP rather than reactive. Yeah. And to paraphrase what you said earlier, perhaps is a lot of CI operators don't know what they don't know yet. Yeah. There's a lot of unknowns out there. Okay, sorry, Benoit, on the final points on that, enablers, barriers?
Maybe to reflect on what you said, I think, well, what is, we don't have to forget the goal when we say protecting critical infrastructures. What is the final objective? It's to limit casualty, to ensure, as you said, our R&D colleagues from EDF said about safety, which is the priority. So you want to achieve the less casualty as possible. Yeah. So you try to accommodate with some degradation of services. So we have to think about that, and what and I think it's, again, each living lab will show that. I think in the project, it depends on the field and on the threats, the acceptability of degradation of service will be very different. Whether it comes about whether we speak about health, whether we speak about traffic, it's different. I mean, the priorities are different. So I think this is something that the tools, the solutions that we will develop, the trainings, etc., have to take into account at any point. What are the ultimate goals of protection? What is meant by protection?
Absolutely, yeah. I think we're going to have to start wrapping up quite soon. Sorry, one comment from the floor.
Yes, I've got a little question. First, a comment again, and after a little question. Yes, I agree fully with you, what you said finally, because at the beginning, we focused on the problematic of cybersecurity, physical protection, tools around that, but the real problem is not that. The real problem is the threats, and then we have considering this, we have objectives of protection. Then cybersecurity, physical protection are solutions. That's why our project exists. Why we have to develop many things, and so I've got two things in mind. By my side, I appreciate the framework from the NIST about cybersecurity. I'd like to have your point of view about the correlation we could have with the physical protection in the way to approach problematic. And secondly, I understand that with the extended company, the augmentation of the landscape with the critical infrastructure, the connections, all the new technology we try to implement, we also have a problem with the supply chain, and I like to have your point of view also with that.
Any quick answers to that?
Sorry, I don't understand. Finally, the question was.
your point of view about supply chain that could bring some issues for the protection of critical infrastructures first. And secondly, your point of view about the framework of the NIST, if you know it, and the correlation we could have with the physical objectives in the protection of the CIs.
Sure, I don't know the NIST directive.
The logistics, I think it's something that operators have in mind in their daily business, of course. I don't think we address that very much in the PRECINCT project, as far as I remember. I won't give more information about that, but that's clear that this is part of the chain. I don't know if in some living labs we are really considering logistic issues. As far as I remember, not. I'll ask my colleagues to help in answering that.
Perhaps we can take that one offline.
Yeah.
Sorry,
Mark, may I?
Of course.
Okay, thank you for these two excellent questions. I think that this is really a very important point of view. We will, we have opportunity to see the logistic problems, especially in China. And for sure, a lot of critical infrastructure or operators are connected with these problems, and we should face and analyze this as one of a critical point of view regarding the business continuity of our critical infrastructure organization. The second part I would like to stress is, of course, NIST directive and question how to join the cyber and the physical world. We constantly warning this and raise this problem in a national and also in the international debates. I remembered in Defender, this was the project related to the energy domain, where we already indicated this problem, that these two words regarding the directives, we have on one side, we had on one side directive of critical infrastructure protection, on the second side the NIST directive. And what this look like into the national environments. So two different ministries run this, directives and the laws. So in Slovenia, for example, the Ministry of Defense is covered the law of critical infrastructure protection, and the other ministry is, dedicated to this NIST directive. And of course, we have in the operational side the mess, because nobody really don't know what to deal in, the comprehensive approach to the problem. And I am glad that now slowly, but in the right direction, these two directives slowly merging in, probably in the future, in one document, one process, one understanding, one operational, understanding of the procedures, and this would be quite good regarding the quality of the process regarding the protection of critical infrastructure, regarding the physical and cyber world.
I think we're afraid we're going to have to wrap up now, and we can take that offline afterwards. Fantastic discussions and really interesting points from all the panelists. From my perspective, I think, we talked about being customer centric earlier on quite a lot. In PRECINCT, we need to maintain that focus all the way through to, try and position what we are doing in the context of trying to get it adopted by as many
users, customers as possible. So I'd like to, can everyone thank the panelists for their time and input in the usual way. Pass back to Jenny.
Thank you very much, Mark, and thank you again to our panelists and our speakers. So I'd just like then to thank everybody who came today to Brussels, everybody that spoke today, all of our speakers, our guests, and everybody that joined us online. This was our first stakeholder workshop. We will be having others in the project, and we would really like it if you could join us again on our events that we have coming up later on in the year and next year. So please, if you look up precinct.info, you'll find the Precinct website, and you can find our newsletters, our updates, our events, our social media, and you can keep up to date with following what we're doing as well on LinkedIn. So thank you very much to all of our partners and everybody that joined, and we'll close the meeting. Thank you so much.